All right, good evening. Are we all here? I think we're all here. This is like roughly how many of us there are, right? I counted and then I was like, I don't know what the numerator is. I only knew the denominator. So I was like, our fraction is between 0 and infinity of how many I would expect, which is like a fairly high range, right? The only thing I knew for sure is that we didn't have a negative level of attendance, right? And actually, it's true, it is bounded from above and below. There's no way it can possibly get to 0 or infinity. It's just, it can asymptotically approach either one. I previously shared an example of one, I don't know, AI event. And it was my undergrad, like one of my CS professors that I did mobile computing with, who's since become quite popular. Gave a talk at Stanford, which is, I think, where you go when you're famous. But he has this job title of senior scientist. Oh, the slides aren't ready. Never mind. Let me show you the slides. How does this thing work? Okay. So he has this job title, which is senior scientist at Argonne National Laboratory. And senior scientist is one of the job titles that, like, corresponds to being a professor. So we have, like, assistant, associate, and full professor, and they have, like, I think it's like senior research scientist, senior scientist staff science, something like that. Senior, I don't know. So he has a joint appointment with Argonne, and Argonne is pretty interesting because for a while, and I don't think they still do, they had the largest supercomputer in the world, the Blue Gene Q. Let's see if I can get anything to work here. Is that my screen? Okay. I'm going to turn off these lights at the front of the room. Does anyone know how to do that? I'm going to start pressing buttons.
Yeah. You just, if you press the upper ones, will, I believe it's one of the lower ones. I mean, that's fine.
Okay. We're going to do this. And that was lower. That was neither the highest nor the lowest. It was neither 0 nor infinity. It was within our bounded set. When I was working with Professor Chen in undergrad, the problem he was trying to solve at that time was the expectation. We were a little bit late on this. We should have been smarter than we were at the time. The expectation that the central processing unit, which at that time was the dominant form of computing power, which were made by Intel. He'd come to my school from Intel. There's this expectation that CPUs would not be able to continue to scale forever, and that there would be some other form of chip that would take over. And I joined his group in 2012, I think, and in 2013, the first person ran image recognition on an NVIDIA GPU, which kind of changed the world. So anyways, in that intervening time, he's been doing a lot of work arguing from the perspective of both performance and critically energy consumption, we need to be using specialized processors. And he so happened to be doing this loudly and publicly right when the GPUs came out, right? So that's why he's famous. And he's been trying to solve this problem for a while that, in his view, like whatever you think about the climate or anything, I think something that was interesting is he said, well, actually, the real thing holding back computing power is that these things melt. We run too many electrons through them. We run the electrons faster and faster, and eventually the device just doesn't work anymore, right? There's only so much energy you can put through any given piece of silicon, right? So he was always arguing that we should care a lot about how much electricity the computers are using, even if you only care about performance, which is a very interesting and very persuasive idea, right? And so that put him and his research team, I believe, pretty far at the forefront of doing energy-efficient cloud and decarbonization and things like that. Anyways, I haven't seen this talk yet. I just saw it got posted actually before driving down here. So I can't personally recommend it. But this is an example of someone that has a very, very interesting perspective on AI, right? This is just someone that's trying to solve the problem of how much AI can we do? And it's a lot, right? And it's much more than many people thought. So a very interesting talk. I have put this in the Discord and you can check it out. If I press play on this, I will instantly get banned on YouTube because I'm showing someone else's YouTube while I'm live streaming. So you can do that on your own time. So a lot of people don't know what the K in K nearest neighbors stands for. It stands for cable. It doesn't stand for Kendall. Kendall and I were discussing this earlier. It stands for cable, K-A-B-L-E, which is a way that LaTeX documents are... What do you think it stands for, Kendall?
Kendall, obviously.
Oh, okay. I can admit when I'm wrong. It stands for Kendall nearest neighbors. Is the K in K means clustering also referring to you?
What?
Are you also the K in K means clustering?
Yes.
Well, you're very busy. We're going to review the homeworks. We're going to talk a little about regression. There's a 0% chance we'll get both of those things done before dinner, but I didn't make the agenda. Jameson Watts made this. Then we're going to do some pre-processing and boxcocks, which I think is how that's said. I was surprised it wasn't hyphenated. I could not figure out what this thing was. This is two people's names. That's why there's a capitalized C in the middle of it. But I'm really accustomed to when an algorithm is named after two people's names, there's either a space or a dash. So this really confused me. I suspect the reason there's not a space or a dash in there is because this is used as a function in programming languages so often. They just took the dash out, and it's just a little bit too common. But I would have expected it to be BC then. And then we're going to look at the K nearest neighbors algorithm and the confusion matrix. We've looked at a few different formulations of confusion matrix so far, and we're going to look at a specific variant of that today. I didn't know this when I started working my way through these slides, but there's a sort of an elaborate reveal towards the end of class today. There's one of Jameson's favorite parts of the course. So keep your eye out to be shocked and amazed. And it was actually pretty cool when I saw it. And it's led me to be thinking a lot about this data set recently. I think you all know, like, none of us are like super duper wine snobs in here, right? But we're pretty smart. And so there's still things we should realize and have opinions about and think about, right? And so that's a good thing. Okay, we're going to review the homework because I've read all of your homeworks for the first one, and I have read some of your homeworks for the second one. Here are my remarks. I think we should work on writing quality, and I mean that in the following sense. It is very difficult to interpret the meaning of two adjacent sentences if they are not separated by clear punctuation. And one of the reasons for this, right, is that, like, the abstract syntax trees that are formed by English grammar are wildly ambiguous. And one of the reasons that all of the programming languages are very rigorous about where we put things like new lines and brackets and stuff is because you have no idea what people are saying unless they follow all of the rules. I would encourage you to approach your technical writing with the same level of technical precision as you do writing code. As I was thinking that while I was writing these slides, I got a message from a student that said, I did exactly, not for this class even, said I did exactly what the slide said and the code didn't work. And this student had changed almost every single letter in the expected code, right? Like almost every single thing had changed, right? And so I don't know what happens in between, like when I very politely, in my view, ask you to run a like very specific piece of code, and then the code that I see mostly undergraduates write. So like maybe there's an error on my end or something, right? But it is important to have like very clear communication around these things. I have been enjoying going through these slides, which are ambiguous and are incomplete, and figuring out what Jameson and Hendrick mean by all of them. And I'm able to do that because they write at a clear enough level I can figure out what they mean. That said, there's one thing today where I'm pretty sure I found an error in these slides that's been in there for 5 years, and I'm going to talk about it a little bit, right? I think we need to work on root mean square error interpretation. And I'm willing to divide up the responsibility for this one with you all any way you like. In the first 2 lectures, there was a really strong emphasis on, I think, root mean square error as a measurement of the goodness of a predictive tool, right? So if we're predicting something, we look at the RMSE, and if it's lower, it's better. I believe every single student in this class was not just wrong, but extremely wrong on the interpretation of RMSE on the homework. And one of the reasons for that is the RMSE on the homework was taken over the log of price. And I could be wrong, but not a single person mentioned that. And that would have probably, that was the only thing I was thinking about while I worked on this, so that was a little bit surprising to me. I have a mathematical example of how I'm going to explain to me that seemed different. I think we need to work on using summary responsibly. And having written a little bit of code since writing this line, I think I mean like Tibbles or print representation or something. A relatively large number of students, in the sense that I detected the pattern, but I don't know if it was 5%, well, it had to be more than 5% of you for there to be a pattern. It could have been like a strong minority, right? Maybe like 20% of students or something. One of the questions was look at Oregon, New York, and California. And at least on my computer, the default way that printed out was it would cut one of the 3 states. I received a number of homeworks that were turned in that only looked at 2 of the states, even though the question was about 3 states. And students only answered regarding the default summary behavior. Like if someone asks you, hey, can you look at these 3 things, and the computer only prints out 2 of them by default, you have to fix the code. You can't just not look at that thing, right? Because that thing could be really cool, right? So imagine, here's a good example. Imagine I'm listing Nosferatu films, right? And I start with the most recent one because it's on the top of the stack, and I say Nosferatu 2025, right? Directed by Robert Eggers, right? And then I say Nosferatu came out in 1981. And then the good Nosferatu that we all like came out in 1922, right? But it gets cut off the Tibble because that's the third of 3 things, right? So then you don't see the best Nosferatu film. So like this should be immediately obvious to you. I hope you all like Nosferatu in 1922. You can watch it for free on YouTube now because it's been 100 years since it came out. Okay. Okay, I didn't know how to phrase this. This is bullet point 4. We need to work on applying lecture topics to leading questions. So one of the ethics questions was like something to the effect of, I can tell apart New York, California, and Oregon wines at 91% rate. Should I be impressed by this? And I thought the answer to that was obviously no. There's like the rule of headlines. What's this thing called? Betteridge's law of headlines. Any headline that ends in a question mark can be answered by the word no. The neural networks in your brains should have been trained on leading questions on homework assignments to always answer no to them if they say, should I be impressed with this? And some number of students, again, I think a minority, came to the conclusion that 91 was very close to the p-value of 95 and therefore good. And p-values and accuracy are different things. So I'm responding to that, and then I'm going to see, I've gotten a flurry of emails, including some after I got to Salem, so after I looked at these slides, that turned in a homework 2 that does not have an image in it. And that is less surprising to me because working with the file system is hard and annoying, but slightly surprising to me because I provided you with Quarto Markdown documents where the header file was configured to automatically embed images, which meant they had to be changed for the images to not be there. So the default behavior of the homework assignment would have included those images. So let's look at an example. This is the homework 1 solutions. I have not posted my solutions to homework 2 yet because it's not due yet. I was part way through posting them and I was like, hold on. That would be weird. Okay, so this is my solution. That's why it has my name on it now. I'm also going to click on the Quarto Markdown document, and I'm also going to open this. Here we go. Okay. Is this working? Ooh, it's slow. Okay, maybe we will not look at this that much because it is so slow. The Python extension is loading. Wait, is this Python? Why is the Python extension loading? Okay. All right. I wanted to go through just a few things here and take a look at this. This is what mine looks like. Fairness to you, it is hosted on the same website as the rest of the course materials, but of course that also means you can look at that website if you want to set up GitHub pages, right? Blah, blah, blah. Here is the first thing. Okay, let's point out something before that. I got rid of all of the notes that told me how to set this up because I didn't think that would be part of the final submitted turned-in homework assignment. You can post these however you like. I thought it looked extremely cursed to have instructions that had already been completed in the finished document, so I took them out. Here's the code. I added modern drive, blah, blah, blah. I provided a number of columns of form. Let's see if we can do this. Oh, that didn't work? Wait, did it work? Okay. Right, so we can do a side-by-side comparison. Okay. So I kept the abstract. I removed this stuff because this stuff was no longer relevant once I got to the setup code. Okay? This code has actually run. This code has not. You may have all noticed that I don't know how to spell explanation. You can well and thoroughly roast me for that, right? I just complained about spelling and grammar to you. You can hate this. You can be as mad at me as you want for that. You have absolute license to do that. I provided what I believe to be relatively unambiguous instructions, which said, write your line-by-line explanation of the code here. To my knowledge, not one student wrote in that location, and I either got code above or below that, which was hard for me to read. And one of the reasons for that is because this code block was specifically formatted to stand out and be in a different font and be in a different location on the screen and so on. So this made it easy to differentiate the portions of the homework assignment to which I had provided you and the portions of the homework assignment that you would fill out. Separately, keeping your code within this block also ensured that, for example, later headers would not be broken. On homework 2, I know because I've seen it, at least 2 assignments have come in where the caret header is attached to the end of a previous explanation. I'm assuming that's a deficiency in the provided Quarto Markdown document, but I did see it in 2 homework assignments, and it does cause the resulting knitted file to look correspondingly wrong because it's missing a heading. So I wanted to introduce that. This is all unremarkable. I think this is lifted literally exactly from the slides. I don't know that you had to do anything other than copy paste that there. I provided some notes here. Report and explain the RMSE. Okay, I'm going to claim this is correct, and you all need to tell me I'm wrong if this is wrong. Where is it? Oh, that's the other one. Okay. Okay, this is what I claim. I'm going to read this exactly because I think it's correct. As we predict the log of price, that is the measurement of the difference of the log of the price from the prediction, which we can argue that's a prediction of a log, or it doesn't make any difference. This numerical value I claim is highly non-intuitive because it is a post-transform numerical value, which means essentially some log has been applied to this. So what that means at an RMSE of approximately 0.5, which is what I saw I had here, I would expect my price estimation to be off not by 50 cents, not by half of something, but in fact by 40%. And the reason I think that's off by 40% is that I think the inverse operation of a log is exponentiation. So I think I should take the exponent of something, I should take it to approximately that 0.5, And then blah, 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 I should do a bunch of things and get to this. So it's much easier with an actual example, which is that if I predict the price to be 100, and I take the log of 100, I'm going to open Python. Sorry, I have to open Python because I don't know how to open R. Okay, so I have e here. We'll just say e equals. Okay, so 7p.log. Yes. Okay. So if I take the log of 100, that is 4.6. So if I have a wine that costs $100, the log of the price is 4.6. Not $4.6, right? This is 4.6 nothings. This is 4.6 some like abstract measurement. We could say, for example, it's the score of its price is 4.6, right? And that 4.6 corresponds to the power to which we raise e in order to get the actual price, right? So if I'm off by 0.5, right, I would expect being off by 0.5 to be 4.1, off from 6. And so if I raise e to the power of 4.1, I get a $60 expected price. And similarly, if I am off in the other direction, I'm once again off by 40%, and I can see that because 164, I don't know how you do percentages, right? Yeah, so like either way, I'm off by about 40% of the expected price. I think the general consensus in this class was that a RMSE of 0.5 is quite good, and I would say that's pretty bad. I think wine in general doesn't have like that high of price ranges. I think like the absolute worst bottles are pretty much at a floor of $15 because of distribution costs, and the prices like go really high, but that's pretty anomalous, right? The best mainline mass-produced bottles, I think in Napa Valley, are like not really going over $250. So you have like a fairly narrow range there, right? And I think, so the log of 15 and the log of 200, those are only about 2.5 apart, right? So over the expected range of how high I would expect logs of prices to be, a root mean square error of 0.5 is like a 20% miss, right? You would be off by 20th percentile or something like that. And you never necessarily really wanted to be doing percentages of ranges, I don't think, but that was my impression. Okay, having said all of that, am I making sense at all? Does this seem like, okay. The units on that 0.49 whatever, they're logs of dollars. Like it doesn't make sense, right? Like that's, I can't go out and like spend a log number of dollars on something, right? Like, so when we start applying these log transforms, the data becomes much more nicely behaved, but our intuitive attachment to it might be quite a bit lower. So I said this was actually an atrocious error rate. Okay, there's one other thing to think about as well. I was talking to my partner recently. Some of you may have been thinking about the economy for a variety of reasons, and so we were thinking, like, where do we put our like life savings, right? And we're like, we should buy gold bullion because that's what people do when they're panicking, right? Yeah, you buy gold, right? Yeah, you buy, what is it, like gold, guns, and cars or something, right? I don't know, like, and so we're like, oh, we should buy gold. I don't know what the price of gold is right now. Why did I just Google? This is useless. I don't know. In US dollars? Okay, right. Okay, so I think that's $90 per gram, we'll say. So one of the things I could have done, and perhaps this would make more sense, is I could have listed all of my prices of wine in grams of gold. This would have been a linear transform. And so if I had a $30 bottle of wine, that is worth 0.33 grams of gold. And if I had a $200 bottle of wine, that is worth 2.22 grams of gold, right? Wait, no, that's not what I want to do, right? I want to say 0.33. And the log of 2.22 these things are much closer to the same distance from each other as they were if I was working in dollars or not. That's pretty interesting, right? What I think this means is that your log price is the same regardless of the currency, or the root mean square error over the log price is the same regardless of the currency, but the difference in actual price is not the same regardless of the currency, because a $200 bottle of wine is $170 more dollars in price, but a $200 bottle of wine, regardless of whether you buy it in gold or euros, is like e to the 2.5 more or something. Is that right? Did I do that right? That doesn't make sense. Because these things are what? These are 1.9 apart? I think I subtract this. Wait, what do I do? I need to subtract the difference. We have to check it. Did I say 30 and 200? Is that what I said? Right, okay. So, regardless of whether I'm buying things in gold bullion or US dollars, my log price, root mean square error, is unaltered. And so, for example, if your interpretation of the root mean square error is that it is off by 50 cents, that is a problem, right? Because this is an error of -2 or +2. It's an error, so it's an absolute value. Are you all tracking that? Does that make sense? Okay. I want to be clear that I do think it is relatively confusing that we are taking the log of something, the log being perhaps the least intuitive mathematical operation, and then we are taking square roots and squares of that. So we are applying polynomial transforms to exponentials in order to get the root mean square error of a log of something, right? What that would then suggest to me, I'm going to go back to the thing I was already complaining about. There should be very clear writing about this, because that is a confusing idea. So you should say, we take the log, which is some transform, and it has these behaviors, right? And then we take the root mean square error of that, which does some interesting things. So the root mean square error punishes you for large misses much less than it punishes you for near misses, right? I don't even talk about that. This is probably not something that earns a perfect score, right? One other thing that's going on here that might be interesting, this is LaTeX. How many of you know LaTeX? Do any of you know LaTeX? Some of you know LaTeX. So you can just write LaTeX in Quarto. I don't know if you can write it in R Markdown documents. It looks like you can, right? But I was able to use a prox here, which was really nice. And I had built-in E and stuff, so you can just start writing LaTeX in your homework. Interaction models. Right. Some, I think, relatively small number of people thought this was multiplication. No, it is not. This is the formulas API. The formulas API, to me, I perceive as underdocumented. The way I actually figured out what it was is I did a bunch of tests and figured out what it was myself, and I've shared with you that Colab document, so you can assess it as well. But be advised when you're doing these interaction models, if you're going to make some strong claim about it, test it and make sure it's possible that's true, basically. Here's a root mean square error. That's fine. That's not too exciting. Oh, yeah, I do an actual example here. You can do this or not, but I noticed I expected something to change by 13%. Right. This tibble, or these tibbles, they don't have the states in them, right? So the reason I wrote a map of the Cherry impact, which is a function, over a vector of 3 different states, is this a vector? Who knows R? That's a vector? Okay. So I mapped a function over a vector. And the reason I did that is because when I tried to generate a tibble, I could never see all 3 states at once. I read many assignments that were turned in that had 2 states in 1 tibble. I claim that that is as wrong as it is possible to be, because it does not answer which of the 3 states, right? That is equivalent to not answering this question. So the way I solved this problem is I wrote a table. I'm guessing the R power users know some good way to solve this problem. I do not, so I solved it this way. And I thought this was pretty interesting. You just see the difference in the Cherry estimate, right? And you also see differences in things like the p-values are all 0, I guess. I don't know. Pretty interesting. Okay. All right. Some of you said exactly this, but you should all know this. If your model to distinguish New York wines from those in California is to predict no, you have 91% accuracy exact. So this is exactly the same as not doing any work. So this is a 0% on your accuracy model. Because it is 0% effort, you can get 91% accuracy with return false. And return false does not constitute a model, right? Blah, 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 ethics. I'm opinionated on ethics, so you can read what I think about ethics, and I'm not going to make you listen to me about it. Okay. Yes, question.
I guess I have two kind of questions. One, you mentioned some setup code for making sure like the graphics show. So I'm just unsure about where that is.
I'm going to see if I can find that, because it was not where I thought it would be.
Okay.
Thank you for that question. And let me see. Is this going to work? All right. I'm going to say I did not provide that code, so I'm going to find a way to provide it. It is not where I expected it to be. I am going to show you. I have some documentation on it. No, that's not the slides for today. Okay. Please go back. No, okay. Okay, nearest neighbors. Right, this is a link. Okay. This is not easy to find. I do not expect you to have found this on your own. There is more than one way to render an HTML web page. And one of those ways, this one, called embed resources, I'm not going to zoom in on that. You don't need to read these words. This says no external dependencies. How does that work? Every single bit of information or piece of information or image or line of code or anything else can be expressed in some way in some computer readable language. And usually this is in base 64 binary encoding, which is out of scope. What this means is that there's a way to convert an image, such as one generated by ggplots, into a series of printing ASCII characters. And you can embed that series of printing ASCII characters in a Quarto Markdown document, and it can all be one file. And I will leave it at that for now, and I will provide more information about this soon because the example I wanted to use is not working. So thank you for your question. You include embed resources where you would include format HTML, and I think you might have to specify it as true. Do I have an example anywhere? What's this class called? Data 505? I keep thinking it's Data 550, which isn't particularly useful. Are any of you doing the Python versions? It's work for me to do them. If no one's using them, I'll stop. Raise your hand if you're doing Python. Okay, I'll keep going. Okay. This heading includes a variety of features, and it was well hidden. I don't expect you to have found this. This is how I specify that embed resources is true. What this means is that if I go back up one level to the HTML documents. Oh, look, Jameson mentioned. Jameson mentioned? Okay, all right. This file has no external dependencies, in theory, which means that if I open it after downloading it, oh, is it still downloading? Everything shows up. So this has all of the correct coloration, it has my font choices, it has the code blocks, right? So the use of embedded resources solves this problem of passing around images. I keep standing where I can't see you, I'm sorry. Good question. So I'll think about some way of explaining that better. And using embed resources is like can be kind of annoying if you're making a bunch of files because it duplicates a lot of things. So the trade-offs for me as a member of instructional staff are, by showing you to use embed resources, I think you can get up and running faster, but you will be annoyed later on in your life. And so that's what I'm trading off between. But when I started using Quarto, I used embed resources for a while before switching over. Okay. Homework 1 solutions posted. Okay. I took a graduate level machine learning class in apparently 2015, which I found out by reading my homework assignments. And in that class, I thought this would be interesting to you because I was looking at it, so I needed some samples of my writing to see. The expectations for that class were to write code, embed code in a LaTeX document, typeset the LaTeX document, and then turn in the LaTeX document, which I would note is conspicuously similar to asking for a rendered either knitted HTML or Quartoed HTML, with the assessment that HTML is becoming the dominant format competing with PDF over the space of the last 10 years. So I wanted to give you an example of what this looks like. This is my homework 1. And you can resoundingly judge me for some things, which is that I left some of the instructions in, right? And I specified the point numbers. I took the points for each assignment out of the homework before I gave it to you. And so everything is worth the same number of points now. The only thing I would like you to take away from this is that in October 8th, 2015, 2 years after the machine learning thing was getting kicked off by GPU documents, the expected way that academia had converged on to teach machine learning instruction is typeset tiny code blocks in human readable documents that are, well formatted and can be printed out. And so when I'm asking you to do all of this, it is based on my understanding of the best way to sort of articulate the learnings of a machine learning class and what is expected for you to do as a machine learning trained person in real life, which is essentially you're going to write documents and send them to people that can't do math, and you have to be convincing. In this document, you'll see, for example, this is what passed for data visualizations in 2015. You should be much better at this now, right, because of the benefit of ggplots. And so the first ggplot request came in on the last homework. And there you have it. Right. Everything is typeset, mathematics, code blocks, and technical writing, which are, I think, the 3 things. You are taking a relative light in mathematics machine learning class. That's okay. I don't think this has like a multivariable calculus prerequisite, which was common in 2015. And the images were all embedded. In that case, my images were both embedded in the LaTeX document, and I also provided source code that could compile the LaTeX document. So the images I used were included in the GitHub repository, and separately from all of that, the code in the LaTeX document described how to render those images and what we were using at that time, which was MATLAB. Very early machine learning days before it was done in other languages, right? I called this Throwback Monday, which I thought was fun. Okay, you don't have to like that if you don't want. Okay, so I've given you what I think to be hopefully some useful food for thought on homeworks and getting the most out of the homeworks in this class. The thing that is gnawing at the back of my mind, as I talked to my good colleague, Professor Jed Rembold, who you all have for SQL probably, or perhaps you had in the past. And so I'm worried because I think Professor Jed Rembold is running the capstone this summer, which means many of you will go into a class taught by Professor Jed Rembold, and then he's going to notice how much or how little machine learning you know, right? And so while I don't necessarily care what happens to anyone else, what you learn in this class will reflect personally on me, right? And so let's focus on what really matters, right? And so what I want to hear at the end of this summer is, wow, Calvin, we all suspected it, but you really are the greatest machine learning professor, right? So in order to support my personal goal of hearing that from Professor Jed Rembold, whose accolades we are all seeing, I don't know, whatever. And if it weren't Jed, it would be Rachel Brown up in Portland, and I want to hear the same thing from her as well, right? So if you're going up there for the capstone, I want to hear the same thing as well. So take a minute. You may talk to someone closest to you, but you might want to talk to someone that has solved the problem you're having. Take a minute and talk about homework 1, homework 2. You can talk about homework 3 if you want. I'm assuming you haven't started it. But do what you need to do with the benefit of your colleagues being here with you right now to make sure we're getting up to extremely high quality homework submissions by homework 5, which is the last homework before we go into the modeling assignment, right? So start talking to each other right now. I'm going to start a timer for like 20 minutes, and then we'll loop back. Okay. Where did it go?
So now what you mean by the HTML, like not loading images? Yeah, because when I like load it on my laptop, it shows it. But when I send it to you, I just download like the version I actually sent you, and now you don't.
Like I understand.
Okay, got it. And this also suggests, I think, like, a very important takeaway about the process.
And then I can
Which is like, before you send
search
someone
and take whatever output
perhaps
and
you might already know it's going to work
to
that
what I
way.
think is correct. But I
Yeah.
I don't
And
know
so, like,
what's telling
one
me why we're
thing, I
doing
mean,
it.
like,
What
it's
is
like credit.
you know what I mean? Like without having a class that we don't understand. Right, the code
Learning goals of this class don't include getting any more hours.
Yeah. Because like when I like looked at it on my computer, it double checked that it worked by opening up the HTML. Like it shows the images on like my side. Right. Yeah.
There's this famous thing with the works online machine.
Yeah. Yeah.
Like, someday you'll have to say,
You learn it, yes.
presumably still
This
for
I
a few
like
years,
because
you
it's
have to
I
have
know
done
that's what we're supposed to do.
Yeah.
I was gonna write that by
and if it just
myself
doesn't
and I
load,
was
they'll just like,
Yeah.
it's like relatively low code, but if you want to take over the world, like,
yes, like without the lines and without
you want Professor Jeff Rumpel.
like you can give me all the information
You're
because
not
I would know what it is. Silly names.
I had an issue with that. Yeah, I just
Now I do after. But when I first read that, I was like,
Yeah, so like,
I'm trying to look at
I saw them not receiving
I didn't feel like that.
sounds like you don't they want to.
there's something I'm learning.
Because whenever you save everything, it makes it and then if it's all I didn't know how to, but I didn't have this pretty
Well, it's not like I've done.
Yeah,
and it's always said it's a solo file, and
I think it's
and I won't always know, right? There's a lot of things, maybe I'll think they were better, however, it's just like someone else with a different style. That's always going, right? And so things like maybe that, if you think it looks good, I'm not gonna leave you, I would just like you to try it.
What features did you make?
I ran it on.
No, you also did price
It's a feature.
There's copies of it, so it's, you know, that's a problem. But hey, it's
Yeah.
If you happen to know what this is, I've been having this error and I haven't been able to get past this question right here because it says runtime memory limit is 16 bytes.
Yeah, your computer's old. Use fewer data. You like sample half of it or something, or sample 10% and just keep going.
Okay.
Yeah, don't worry about that. Like you can't. I can fix it, and it's like the solution is to like have your boss buy you a better computer. So.
Yeah, but I can't do that right now. But
Yeah, right. So yeah, just sample.
And then so the computer is drawing lines between
Is not by any means.
and so that's how
I was so confused why it was taking so long to do it, and then I was like, "Oops, I forgot to remove all of the other columns."
Yeah, it's taking 2 hours to load. One known chair, and I say here's a table. It would just say chair. It would just say chair.
Oh, yeah.
Eventually, when it learns more, then it can make more specific lines. But if there were only one, it would just scan the ones that it just go up.
Why is Discord not
If
loading?
you could put that on Discord, then.
It's like just not loading. Okay, there it is. This computer is not doing well. Actually, oh, here's what I should do. Let's pause this. It is, and it's
That makes sense.
it's the same computer I did that machine learning assignment on.
And once it scans something, like
I had one Asus laptop, and I loved it, and then I got another one. I hate it.
I would just buy the new one of these. I like this one quite a bit. This is, I guess it's R, but it's also not R.
like obviously the different things for scans one, and they're like, okay, it's different. It's like, okay, this is good, and then it can identify. Eventually, you build up a whole repository of like.
I just did the variance coordinate line from the slides that we did, and I got so many features that I think I
That's gotta have a lot of points for a hyperspectral
created
lens.
wrong, but that's a later problem. And so I ended up basically ordering them by importance and then filtering and doing all the jazz, and ended up with something like
Interesting.
this. Okay. Well, when I originally did it, I had a feature in here called price per point, and then I was like, that was sky high, and then I realized I was like, oh, I'm using price to predict price. So I didn't take that one out. But
Okay. Well, that's the nearest neighbors actually. See, I didn't have explanation like that at the beginning of every class, so because
I
we
think
just go into it.
yeah. Well, like, I guess the thing that I guess makes
Well,
me
I'm
think
like I'm just saying like in general for like these ones, whatever points in that class I would like to know how it fits in.
well, and also part of it is just like people understand like we associate good things with things. But if you tell somebody, hey, that's a 70.1, or like, okay, it's 70 out of what? So, well, it's like, okay, well, if I say and you have no, you don't know what I said, then you're like, that's like a B. Versus if I'm like, yeah, it's $2 wrong, or like, not good.
People don't say like it's like 4.25, then it just becomes 0.25 away from every point.
Yeah.
Okay.
I don't know how you
I re-downloaded it.
Okay.
You have to like make like a GitHub repository.
Okay.
And then name the file index HTML. And then you do a whole page.
Yes.
Okay, so that means that's going to be.
Thank you.
Oh, you do it. Okay. Did you delete partition?
I did for a second.
Yeah.
Oh, okay.
I deleted it when I had it, but I downloaded it just through there to see if that was.
Oh, I got you. I got you.
Oh, okay. Oh, yeah.
That's fine.
On the price, yeah.
We're so fine. I told you it was gonna take me out.
Yeah, at least it's nice to get on your files changed from HTML to just indexed HTML page. And then like you even put it through just needs at least from community that's working in index.html. If you wanted to like open the HTML and bring it to production.
I haven't taken it. I probably should have taken that.
And I don't know where the HTML is.
What's that? Oh, I guess I can do that. Yeah. I didn't name it index because I couldn't get the thing from so it's the HTML so it's not going to pretty easy.
Yeah.
Yeah.
Yeah, now it's
It didn't.
Like the community and yeah, that and then
Maybe I did it
I think
wrong.
That's not what I'm doing.
Ignoring this right here, I just had it like this, and then it just.
Yeah.
Okay. Yeah, so you just have to
Because
send
tomorrow is that like right up here, it just it puts us up here, but it doesn't. It just treats it like a regular street. I thought that did.
Yeah. Yeah, that's it was in the first day of slides.
Right. At least now like the title looks good. Yeah, I don't understand why it's not putting in the right. Oh, that might be better. Try, you know, like the render button? Like, if I did actually, now I think about it, I remember I spelled February wrong, and then I tried just editing the code and then pressing Control S to save it, and then it would still not update the text when I rendered it, and then tried publishing it, it fixed it, so. So, try pressing the left. Yeah, right there, yeah.
This isn't where I usually have it set up, so not like all of the same flow or everything. Okay, it's all just in downloads.
Okay, yeah. That I did the same thing, yeah, I didn't move it to
Is
my version.
it's like I actually do everything.
On the other
PC at home.
That the like stupid anxiety imposter syndrome where nothing I do is good enough, so why should I do anything?
Okay.
I guess you sent the render first and then it loads it up.
And so I gotta keep going. Anything we're doing is worth doing. Why would I turn in something? Turn in something to why not? And I can't get this look good. Because I've somehow broken it to the point where if you go to the GitHub, it's just
Yeah, okay, I think we're gonna experiment.
so if I go to
Or we can do it. Oh, yeah.
Changing it. Okay.
we're not allowed to use I asked him and he says no. First thing at the top of the country says
Cases.
that's how when I was asking Jace, he's like, what is Jace?
Oh, that's the,
I only know.
Save, and then gotta give it a hot second. So,
No, he just rendered. Go through this journey. And I gotta render it again.
Yeah, it works. Essentially because
Is that? How's this work? Okay, let's go ahead and close this. All right, I'm turning my screen capture back on and overheating my computer instantly. Okay. See, the thing is, we know how many electrons it is, right? I'm streaming at 10 FPS on a 1920 by 1080 monitor, and I have 255 color channels each of red, green, blue, and alpha, which means I have, what is that? 32 bits per pixel, 2000 by 1000 pixels. So that's 32 times 2 million, which is 64 million, and I do that 10 times per second. That's 640 million pixels per second. Now, I don't know how many electrons I need per pixel, but it shouldn't be that many because my monitor isn't melting and I can see that visually, right? So where is all of the electricity coming from and going, and why is it being distributed as heat? Because even if I think I compressed that monitor into the size of however big my onboard graphics card is, which I'm just going to say randomly is about this big, I don't know, right? Even if I put all that heat from the monitor in something that small, this is physically cold to the touch at room temperature, right? So I don't know why my computer's overheating. It's using too many electrons for something, right? I should give those electrons back to whoever they belong to in the first place, which is probably to carbon capture. It is now today. No shot is at 7 o'clock already. Okay. We're all working on finding and bringing to justice whoever the professor of this class is. And I will help you look for whoever it is. I'll maybe even leave the search party. Wait, do I need to comment on anything here? I have no idea what this does. Class. Have any of you ever used that before? I think it's used for classification. We'll see. Everything else is already introduced, right? We're pretty much just adding log price immediately by default now. Despite me taking the last hour showing all of the problems with using log of price, it is in fact the best thing we have. And we can actually make some arguments for that today. Okay, we're going to play a game. Okay, this game is called GuessTheCorrelation.com. Have you all played this before? Okay, everybody open GuessTheCorrelation.com and go there. My high score is 72 and Jameson's is 122, which means Jameson is how much smarter than me? So we take the log, right? Okay, so Jameson has 4.8 log score and I have 72 log score. Well, that's pretty close, actually. We have roughly the same root mean square error as the wine estimation does, right? So think about that. That's one example right there, right? When you saw 122 and 72, you should have thought those numbers are about 40% apart. Because, in fact, that is the same distance. It was very, very hard to get the same score that was the root mean square error distance away from Jameson, just so you know. Okay, let's play Guess the Correlation. Is that coming from my computer? Oh, yeah. No, it's fine. I told you to go to a website that makes annoying noises. Okay. All right. Let's go to New Game. I have to log in with an account because it's 2025. Should I log in with my UNC account? Okay. I didn't know I still had that. That just popped up there. Okay. New Game. Please enter a username. Okay. Oh, that was more than 20. Okay. All right, new game. Ooh, I bet this is 0.8. Yeah! Okay,
I
alright.
got one.
I bet this is 0.3. Ah, it's closer to 0.4, but I truncate instead of rounding because I'm not a coward. I did that on purpose. Okay. That sure looks like 0.8 or higher. Ooh, I rounded instead of truncated that time.
Shucks.
See, this is weird. It looks like a flower bouquet.
That was my first one. That's awesome.
Okay. That's nothing.
Yeah. That was not way off on that one though.
Oh shoot, I'm not gonna do 0.09. Not 0.9. It's 0.9.
Oh, I got that one.
Oh no, I already lost a heart. What do you lose life for? I'm taking damage.
When you
And a lot of people don't know this, but damage is long for Damn, which is named after the person that just won 4 Grammy Awards, Kendrick Lamar, his first studio album. That's named after Damage. Okay. Don't put that in the course evals. Okay. I'm getting a bunch of easy ones here. That's 0.39 correlation? Okay, all right. I probably should have learned some statistics before doing this.
That was 0.49? How was it 0.49?
Wait, can you type in one? Can you type in one?
Yes.
Oh, okay. I just put a bunch of 9s. Okay. Okay, that's bad. Well, I haven't even perished yet. I'm fulfilling my goal of being a streamer. I'm streaming myself playing video games. This is what I've always wanted to do. This is just like if I were playing Halo Infinite.
That's 0.1. Oh, okay.
That's awesome.
I'm not good at telling 6s from 4s.
No. That is not 0.26. That is not 0.26.
I'm getting close. I'm getting like.
I got another heart back. I did enough right that I got a heart back. Okay,
I don't know how we get them back. They just show up.
I think it's like 5 or something in a row that are within
Oh, interesting.
or maybe 7 in a row, something like that. Wow. Okay. That was
Oh, score is the number 7.
Oh, look, I got a 72 again. That's crazy. You think this is easy?
Oh, is it 0.05?
I think within 0.05. Every time I did it, it was within like 4 counts.
Yeah.
Okay, finish your games, then we'll check back in.
Okay. Okay. Not 98.
Look how close I got on that. Oh, I got
Just
3
do
hearts
0.9.
If you beat Jameson, immediately take a screenshot and send it to me, and I will send it to him and say it was my score.
That. Okay, you come over
Is-
here and
is
tell
your
me
score
how
the
this is
number
0.43. You come over here and tell me how this is 0.43.
Okay, so it's simple. If you take an estimation, right, and then you calculate the expected error at every single point.
Okay.
Wait,
Right,
but
yeah,
I
so you
maxed
do
out
like
at my
a
heart.
square,
Yeah.
Right, and then you
I
calculate the error
maxed out
for
my
the
heart.
error. To me, I just like...
You can just do it in your head.
Yeah, it looks a lot like... I actually got 0.42.
Oh,
That's because I
okay.
truncated this round.
Mm.
So I think it's probably 0.42.
Okay, got it.
I can't see it at all.
Are you getting your potassium?
I know. make sure that it's, I do the exact same thing. They ought to put the 0 point.
I am getting better.
There. Okay. Wonderful.
That's a good
I got 12, I think it's never gonna be better. I got a 22.
She also was like 22. Great.
How did you get a 0?
I just know what's
In numbers of events, I did give a constant rating, so it do have the best of us and the worst of us. Yeah, that's what I was. Oh, that's cool.
That's like big clusters like this.
I think that was
It was your
it's just one.
This weird.
Wait, is high score coins or is it streaks?
I think it's coins.
What? I had such a high score earlier, but I thought it was streaks.
Oh, my God. This might be 0.
How is that?
There we go. There we go. What's 0.3 again?
Okay, so I know what you're all thinking. You're thinking, how much better do I have to be than Jameson to be as much better than Jameson as Jameson is than Calvin, right? No problem, we can calculate that using logarithms, right? So here we have the log of 122 and the log of 72. All right, so we'll just do a subtraction, no problem. Okay, so that's the difference, right? We're going to store that in a local variable x, right? And then we're going to take that value and we're going to add it to the log of 122, right? Okay, and that's going to be this value, 5.33. And then we simply raise e to that value. And this will tell us the score we need. Ooh, I'm not allowed to do that. Oh, it's bitwise OR, okay. So you need to break 207 to be certified impressive, okay? Well, I think you can't get a fractional score, so you probably have to just get 207, yeah. And if you get 206, I won't be impressed, right? That's not impressive. First of all, it's an even number. Who even cares, right? It occurs to me maybe it was a bad idea to give you the weapons grade time waster right before trying to lecture for 15 minutes before dinner.
I'm not going until that.
Not to worry. Okay, I'm taking my 15 minutes back. All right, so let's look at one example of why it matters that we can estimate what correlation something has by looking at it. And that example is the price to points and the log price to points conversions. So, well, that is comically small text. I'm like looking at it in the back of the room, and so it's like just blending together. So, if you just predict if you predict price from points, right, you have a correlation of 0.4, and if you predict it from log price, then you get, or no, we're predicting price, right? We predict the first thing. So if you predict the price from points, you get 0.4, and if you predict the log of price from points, you get 0.62. So what does this mean? Your model is essentially more accurate if you take the log of one value. Now, I think I have stood here before you many days, probably approximately 9 hours worth of content so far, plus about 2 hours of YouTube videos that I'm guessing you watched on 0.5 speed, which is why I gave you 2 hours of them, right? Or maybe you watched them twice. When I get home from class, I watch these lectures back at 4x speed before going to bed. That's how I lull myself to sleep. So, using nothing other than a very simple feature engineering technique of applying a log to one value, that's a single mutate, right? And it's a single mutate of a single function. We can dramatically improve our correlation. And I know you're thinking, Calvin, that correlation is only 0.22 better. But what we should actually do is we should take the log of those correlations, right? Okay, so we get in here, and we say, okay, we got the log, that's a, right, so we got 4.4, okay, then we've got, what was it, 0.624? Oh, that's about the same as our root mean square error. Oh, that's a 40% difference. Okay, all right. I can stop anytime I want. It's just everything happens to be 40% away from something else, right? Okay. So this is our last exercise before dinner. Your mission, should you choose to accept it, which you must. I don't know why there's 2 logs here. That's on me. Just don't look at this one. I'm going to highlight it so you know to avoid it. Okay, there you go. Calculate the correlation between the log price and the points by variety. And it drives me crazy this is variety. That's surely supposed to say varietal, right? In coffee we say varietal. That sure looks like it's supposed to be varietal to me. See, maybe even the beer people say it. And that's comparatively low class and low culture, I've heard. I would never claim that myself. I drink hop water. Okay, so look at Oregon Chardonnays, Oregon Pinot Noirs, and Oregon Pinot Gris. Sorry, I can stop anytime I want. And put it all in the same tibble. Oh, and by the way, in this tibble, do you notice that you have to display 3 things?
Oh my gosh.
Oh my gosh. Get cracking. You have 15 minutes. Did you do it? If you're bored, you're supposed to do the Python.
That's going to take me longer. This exercise to do all that.
Scikit-learn is really cool. I'm liking it more and more that I've used it. Scikit-learn, I never liked it. I've been using it a lot this term. And I'm starting to like a lot of the things that like it. I'm like, it's making people spend more than 15 minutes in their entire life using Python, which was not the I think there's approximately 1 billion lines of extremely high quality Python in the LLM. I can only watch it this speed. It looks like I'm It's good to feel awkward, right?
Stop, you're making me so Oh, I got 209. 209 and 3 hearts. Let's go.
No way. You're never going to do that. This is so awkward. Okay, there's a lot of people playing the game, but only if your score is over 140.
Yes, that's
It's not currently over 150. If you're 149, you got to cut your losses, and you have to actually learn the program. Okay?
No, those are 2 very different things. Is Oregon in region 1 and what's the difference? Because it's Willamette Valley in Oregon. Wait.
Yeah, that did hurt.
That's fine. Because like I looked at like
Okay, well, I got past
Oregon.
organized.
And like the first thing I saw was Oregon
Oh, this
Region
is
1,
ours.
so I thought I should be.
No, we lost someone at 2:15. Can I get everyone type an F and dip?
Capital P. Oh, yeah, they spelled province wrong. They spelled province.
It should be words.
Oh. I didn't have to.
2:15. That's pretty good.
Okay.
I also died at 2:15.
Oh.
Those last three were really hard though. 3-3, that's way low. I was thinking maybe in the thirds, but 3-3 is a lot lower. Even that would have been like, yeah. The ranges from like the 3 to like 6 range is really hard. They're hard to tell.
Oh, just lag.
I didn't put it this way.
Yeah, because I did this to make sure it worked for me, and then I just copy pasted it over.
Yeah. I got everyone noticed, and then I got a lot of pressure.
You thought I submitted for a third stage. How dare you?
At first, I also thought it was.
Should I just cold email this to do some lots? But did you send me the code? Because I was working on this. Nope.
That's the point, we have to figure it out.
I don't know.
Storage status will not apply. But stables are 12 on the
Yeah, I was looking for documents down here.
He said about the number of brain cells and the stable
Right,
curve.
if I had two of them to rub together, then I could start a fire.
Mine can't start a fire.
With the cake origin.
I don't know.
The thing.
No.
There's like a put of 0.3.1.
There was two reasons, like I had a train of thought.
Another one with the exact same type of one.
And I was not on that train.
Someone needs to get here. Your region's making it. Okay? Alsatia is not.
I think the Europeans have definitely had their fair share of naming things. And I think it's time that they let others have a chance.
Oh, wine is
I
ours.
just don't think that's the most out here. You know, I think it has a name.
That's the first one that
I just said it out loud wrong, so I typed it right.
That was actually.
Yeah.
That was
This all stuff is purely subjective. The code is wrong. It should have been 0.10. It should have been 0.10.
It should have been 0.10. Listen, they can do the. Oh, actually,
I guess.
that one's fair. This one too, I can see some. I can see some. 135. That, I don't. This one.
Oh, I didn't.
I think. Okay, that's good enough.
I'm gonna add 8 points. I'm more of a greater overlook guy.
Oh my god.
Oh, really?
No state, one big United word. Exactly one. Yeah, one big state. I don't know. Greater people have some big points. We do live in a society.
We just call it like a different state.
Oh, I know. I'm talking to like
Not doing like
That sounds like a corner like, in some contexts, I feel like something like that.
That's true.
Yeah.
I'm a big advocate for justice.
living in the gray
Like
areas.
micro offenses.
Yeah, I used to worry about micro, right? But then I realized what you want is
Yes.
it's plausible that I'm still.
Yes. That's what I was trying to say when I realized I said this
Okay, we're
Scroll down.
Oh, yeah.
Yeah, that's what I. Well, not the struggle.
Second.
Yeah, we did it. It's time dinner yet.
That's not over 150.
It's higher than yours.
I know.
Congratulations. I had to get exactly 40% worse.
That was just your goal.
Yes.
Nobody. And no internet.
How was that 11?
I don't have any work.
I get 7.3.
He broke the ruler.
Yeah, you can't. That's an
And I'm not like making a deal.
I think that's why one of my filters doesn't work sometimes.
It's like essentially stuff before 27. Because I remember I went in like stuff like that. Oh, that didn't happen to me.
Because I wanted to find all the Gen Z clients.
I don't know what's. You should keep talking about how you're on. Yeah, we're on a roll. We're so on a roll.
You're so on a roll.
Okay, come on.
See, look.
3, 6. No, way off.
Yeah.
I know that's 3, right?
I like that one. Yeah.
Okay. 6, 9. I'm sure that thing I did not.
Ta-da!
Oh, yes. 72.
I also visualized these. Yeah. And then we'll start talking about residuals after dinner.
Yay.
Hooray.
I have to review what I'm going to teach real quick. See, like, look, dinner is supposed to be here, and we're at like 12, okay? Oh no, I was going to teach you calculus after dinner.
Oh, goody. Yes, 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 yes. Do differential
Get
equations.
that out of here.
Yes, come on, let's go.
No, I have no.
Let's do some discrete mathematics.
I didn't realize...
That's part five, that's right down the line, that's right down the
My math class is not till 2.
line.
This is not math, this is computation. This is not mathematics, right? I was gonna write the epsilon delta proof and I didn't for you, Kendall. Well, I had no idea how mathematically this was gonna look.
I don't know what I'm hating on, but I'm hating on this. I'm hating on this.
We might not get to nearest neighbors today.
I'm okay. I know someone in that class. Distinct mathematics.
look it up. I can find it out.
I don't know. What do you think the script is going to be like ready to so out from now, right? Sorry. No, it's like I don't have anything to do. Like I'm not asking. I'm just wondering, like I'm just asking you, like, okay, I don't have to worry about it for like another 2 months, you know? It's like
Unless you want to help me write it.
you can. Gaz and I can, not just me.
Yeah, I was in the state this last year. Change it to be about this officer in the current year.
You feel like we use all the same things.
Pretty much, you absolutely can, and you should be able to do it. Funny.
You know me. That's gonna be already know. That's
That
just
is the biggest lie I've ever heard in my entire life.
What? I didn't come up with everything. Okay, I'm like,
You're insisting so
Hey,
that you
hey.
can know.
no, I'm like the general idea person. Jazz like to make it like sound without it correct.
So like the jazz is jazz is like the British down.
Basically, I'm the brain. Basically,
That's absolutely not.
you know the truth.
Hmm. Why is this so slow? Why is this so slow? I know it can do this. Surely.
I have strawberry alcohol. I might have hold on, I might have like extra.
Why is this not working? There. Okay, it's fine. Execution halted. L price doesn't exist? Ugh.
No, there was a 1776 aspartame.
Never mind. I'll mutate later.
That's insane. I don't know how.
Oh shoot. No. No.
Oh, that's a good deal. No, let's go wait on that. Thank you. Someone with the math. It's very expensive. I know. That one like every
I don't think it's quite going to be my computer to I would find hot chocolate.
Why is it so slow? It's gonna be wrong. Is ggplot part of Tidyverse? Do you have to include it separately?
Yeah, different flavor. Yeah, but it wasn't tight. I thought it's different, but
Yeah.
it is. Okay.
Why do I have 3-4 browser windows open? What is it doing?
Is 4, are you saying 4 Chrome tabs is bogging down your computer?
This one can pretty much handle one tab while it's streaming.
Oh, cool.
Yeah. It's all streaming. Streaming is the dominant load.
Yeah, go to Task Manager.
It can't load Task Manager, it's too overloaded.
Oh, really?
It's hot to the touch.
Oh, come on.
Yeah, look at this. Wait, I have an anti-malware executable? That explains a lot.
That is an annoying thing. I have that disabled on both of my computers.
Yeah, I didn't know it was enabled on here. But like presumably I don't need all of those things, right? Okay. Here we go.
Using a Mac or RAM.
All right, here's a ggplot test. Okay, default, whatever. This is in downloads. Okay, we created a demo. I wanted something I could type without talking while we were coming back into the room. Downloads. Here's demo. Okay. Is that an image? What is that thing? No, that's how the image is saved, as text. That's how you embed images. You don't believe me. I know you don't believe me. That's okay. I don't believe me either. Okay, no problem. We'll open this thing in. What's everyone's favorite text editor? Notepad. Notepad. You're like, oh yeah, this looks normal. This looks like HTML, right? This seems fine. Oh my gosh, what did I do? I don't know how computers work. Okay, we're fine. There's whatever clipboard.js is. Okay, this is looking a little bit cursed, right? Maybe we don't love that. Okay. So you never look at these things if you remember them with embedded resources, right? But okay, all right, we've got some functions. That's JavaScript. Can I hear a whoop whoop for JavaScript?
No.
Most popular language in the world. More speakers than English, I believe. Okay, that's the end of JavaScript. Not to worry, we got more JavaScript. Look at that. Oh, there's some more. Okay, all right. So this is what an embedded resources looks like. We can scroll down a little bit. And there you go. I don't know. Let's see. What's an example of something I put in this file? So we have scatter plot of. I can maybe find that. Ooh, all this. We'll look for include some data. Okay, here we go. This is where the data is. You'll notice we're very far the way down the page here, right? So this is not a nice file for humans to look at. This is a nice file for browsers to look at. This is for browsers, okay? Here's the term ggplot. You can kind of see in here all of what's going on. This is a presumably like a function coloring, because that's the same as geom point, right? And then up here we have a different style for ggplot. Okay, and then this is what the image data looks like. It is an image of the PNG file extension, and its data is encoded in base 64. What does base 64 mean? There are 64 different characters here that are holding 6 bits of binary data. It is the alphabetical characters, upper and lowercase, the numerical characters, 0 through 9, and then I think it's also like exclamation point and caret or something, because that gives you 62, and they needed 2 more. Because 26 times 2 plus 10 is 62, which is not a power of 2. So they found 2 other characters, and we can probably see what they are. These appear to be perhaps line breaks or something. I don't know. Anyways, this is image data, and this is image data that you can open with your browser. Probably. Where to go? So I think if I take this and I go to the end of the quote, which is not going to be something that's going to be possible to do for my OS's file buffer, probably. Let's see. There we go. There's no way this works. Okay, and so you can manually type in raw information. Raw as in unprocessed, comes with no context, right? So that's not a URL. That's not going anywhere on the internet. This is just actual file data. And this is pretty interesting because you can do things like edit it, and most of the bits don't matter. But if you get enough of them, it breaks, right? So that is a poorly formed image. Cannot be displayed because it contains errors, right? But if we go back here, let's see. Anyways, I tried to get really good at manually editing image data, and I couldn't quite ever do it well enough to just type it in. Okay, so what's this demonstrating? Well, it's demonstrating 2 files I'm going to upload directly into Discord, which is this demo, which is the HTML document. Do not mess with this. It's just that you can open it, right? I want you to know what it looks like. It looks horrible, right? It is very, very close to just being a program. Okay, and then this is the Quarto Markdown document that created it, as is. And I think, personally, we can debate the merits of this. But the default Quarto Markdown, I think, looks quite nice, right? This is all fine. So if you're turning in something that looks worse than this, which is up to you, this is not an aesthetics class, right? You took a data visualization class. Here is an example of something you can mess around with. Okay. And by the way, please do ignore how I made this data visualization, which is that I asked Copilot to make it for me. And it did a bang-up job. Good job, Copilot. Okay. We're not guessing any correlations. We already know our correlations. See? They're right here. How's everyone doing tonight? Are you locked in? Cool. I've never been so locked in my life. Which is good, because not too long ago I saw this residual plot, and I was tempted to say, that looks fine, right? You were tempted to say that, right? You were looking at this, you were like, that residual plot doesn't look that bad. But no, look, I cleverly drew some red lines on it showing what the problem is. What is this? Okay, so first of all, what is a residual? Actually, can someone shout it out? What's a residual? Okay, that was a good job shouting it out. You all seem very confident. So the residual is what's left, the residue, between the prediction and the observation. And sometimes we do some modifications to it, right? So if we are creating models that are well-formed and proper and good, what we should expect to see is we should expect to see no correlation between the residuals, which are these dots. If you don't believe me, it says, see, I plotted the residuals right here. Oh no, I plotted the residual singular. Sorry, this is only one residual. Okay, this is a residual plot. And what we should not expect, if we have well-behaved residuals, is that the error increases as the price increases. That should seem bad to us. That violates one of our assumptions of linear regression. And we don't really want to go in and do the math ourselves. I learned recently by listening to some of you all when I showed equations on the screen. So if you don't want to do the math yourself, you're not allowed to have this feature. Now, this is very approximate, right? But I could have gone in here in ggplot and said, hey, just put me put some quintile lines on here or something, right? Or quantile. What's the difference between a quantile and a quintile? There's also quartiles. That's another thing. So there's 4 quartiles. There's 5 quintiles. And a quantile is any discrete amount, right? So a quartile and a quintile are both special cases of a quantile. That won't be on the midterm. Oh, maybe it will. I don't know. Okay. There's a midterm in this class. I was checking the schedule. There's one. I don't know what's going to be on it. I'm going to take it too, and we're going to see how I do. Okay. So here's an example of a good residual plot. Why is this? Well, we don't have our residual size increasing as we increase in points. You could argue, wait, Calvin, isn't there less residual at the beginning and less residual at the end? That's because there's less data there. That's my claim. I claim there's no correlation between residuals and points. You've all been playing Guess the Correlation game, right? What's the correlation of this graph? Not a lot. That's how much. Okay. I think you all know what coefficients are. Oh, okay, this is the second time LaTeX been copied. So something happened with my rendering, right? Because that's e to the x minus 1 times 100 right next to e to the x minus 1 times 100. I wonder what happened there. That's very interesting. Here, you all love HTML, right? Yeah, that doesn't help at all. Okay. Okay. So what do we do here? We created a model. You all remember regressing Laprice to points? Laprice is, of course, is there anyone in here that's French? That's the French price. Laprice. Okay, all right. Then we're going to filter wine, and we're going to make sure its province is L'Organ. I don't know. That was the best I could do at short notice, right? Then I'm going to create a variable called %. This is, okay, I'm sorry. First of all, this is terrible. I say single equals instead of arrow aside. So that's me being a little bit too Python pilled. I'm sorry for that. Okay, so I wanted to create a local variable for % because I was going to show it off in this tibble here, right? And so I take the percentage, This is the way I extract the coefficient from the model. So what is this? Model is referring to the results of the linear model based on the price and points, okay? So I'm going to look at the coefficient of the model, and I'm going to look at the coefficient of what value of points. I'm going to subtract 1 from it. Why is that? Well, this is a percentage difference. So I'm going to get the amount percentage change based on the coefficient, because this is a log. I'm going to multiply it by 100, because humans like to think in numbers that are not approximately 1/100th of something, but are one of these nice, I don't know, roughly the number of fingers I have, right? Roughly this many. Like my pinky is like struggling a little bit, but not too much, right? And so this is how much a 1-point ratings increase corresponds to. Why is that? Well, the price is a percentage change because it's logged, much the way the Pacific Northwest is being logged. Climate change, one of the university's 3 strategic goals. Yeah, okay. And then points is the measure of goodness of something, right? So a 1-point ratings change is a 9.85% increase in price. Okay, I am holding a bottle of wine. It is a 90-point wine. No, yes, it is. 90-point wine is fine. And it costs $30. And the phone's ringing. What is this? Oh, it's Wine Enthusiast. They say they gave me the wrong number for it. This is actually a 91-point wine. How many dollars should my $30 bottle of wine be now that I know that it has 1 point higher ratings? I think I heard 33. Do you want to use a lifeline on that, or do you want to lock that in? We'll lock it in, 33. Unfortunately, 98.5 is slightly less than 3 of 30, so you're within 40%. It's good enough. Okay, so here's another one that I thought was pretty fun. A lot of people seem to care a lot about the price of things. And there's a measure of price. It's called inflation, which is also what's used to make balloons go up, right? So that's 2 good things. Sorry, I had a little bit too much caffeine 5 seconds ago. Okay, so we can do the same operation here. Oh, and by the way, when you look at this, you should think, Calvin, why did you not just write a function that does this? Oh, no, maybe I should have written a function. Okay, so anyways, I checked to see if year predicts price, because I suspected it would, weekly, right? I expected wines would cost more over time by roughly the rate that the consumer price index is increasing in the United States, because it's the world's largest economy, or at least was until 2021, which is after this stuff came out, right? Do we think the European Union is one economy or more than one economy? What do we think? Just think about it, right? You have to have an opinion. Okay. So anyways, I checked how much prices were increasing by year, and what do you know? It's 2%. And it's 2% from about 2010 to 2015, which is roughly when most of our wines are, and that's how much inflation was going up in those years in the United States and in much of Western Europe as well. And that's where many of these wines come from. And I think the ones that don't come from the United States and Western Europe come from New Zealand, which I believe was also inflating at roughly 2% a year at that time, right? It's where wine lives. So I don't know about you, but when I see someone making strong claims about what happens to exponentials, I either make a graph of them, which I don't know how to do because I haven't made a graph since I was in middle school, so I learned all of my programming languages without knowing how to plot the f of x of anything. So instead of doing that, I simply wrote a for loop where I looked at a bunch of different numerical values and saw how much things changed. And please stop clicking, Calvin. Okay. It's important to talk to yourself sometimes because other people won't. Okay, so one of the things I noticed here is that if I have a 0.01 increase, that corresponds to actually slightly more than a 1% difference, because I think this thing squared has to equal that much or something. And what I want you to look at here is when we're looking at this exponential change percentage conversion here, what's going on is at very small numbers, so like less than 10%, 0.01 is very close to a 1% change. And there are 2 zeros right here, 2 zeros before the 5, which means that the difference from this being an absolute percentage is quite small. And that's because, well, at least the way I think of it is this 0.5 is basically splitting the difference between the 100 and 101, which we're taking the sort of, I don't know, compound rate of change over time, for lack of a better word, across that value. So we would not expect this to be an exactly 0.0 or 1.00 repeating. When we go up, when we increase the amount of change by 10% from 0.01 to 0.1, correspondingly, this 5 term also increases by about a factor of 10, but it increases relative to the base rate. So what this means is that at higher increases per year, if we're increasing the price of something by, for example, 50% per year, the compound rate of change is 64% at a time, right? This was pretty non-intuitive to me and non-obvious because I would expect that if I have some coefficient in this range that it corresponds to exactly these percent changes, but in fact when your coefficients get really big, if you have a 1.0 coefficient, this is essentially e to the 1 minus 1 times 100. E to the 1 minus 1, and that's 171. So these natural log increases get pretty weird pretty quickly, and so I think what's happening here, somehow if your price is doubling every year, there's some larger percent change. And I have no idea what this means, but I just noticed it was interesting. Okay, we always like to show you how to write a program that does your homework for you, so that's well and good. Here's a good example. You can print a string that says for v in varietals. V in varietals is, oh, this is a vector. I love saying vector. There was a student in one of my discords, not one of you, that was asking about vector arithmetic today. And I didn't know what any of the words were to talk about vector arithmetic. Do you all know what linear combinations are? Do you know how to describe them without using any words related to linear algebra? Because I tried to do that today, and I don't know how to do that, which is why I'm not allowed to teach mathematics. So if you see something that you think is mathematics on these slides, be aware that it is either data science or computer science. Okay. Okay. Summary. If you have taken the log of the dependent/response variable, which is the predicted one usually, right? Exponentiate the coefficient, subtract 1 from this number, and multiply 100 to get the percent change. This says percent increase. It should probably say percent change, but I don't know. You could argue that a negative increase is a completely reasonable thing to do. Here's another one. What is happening? Look at that. That's cursed. That's terrible. I got to see if it does that in another browser. Do we have any? Okay, we'll do raise hands. Anyone use Microsoft Edge? I respect that. It's good of you to be honest. Who uses Apple Safari? Very nice. Yeah, we got a Safari user. Who uses Google Chrome? Who uses Mozilla Firefox? Any Brave users? Brave was the next most popular last time. Okay, what didn't I say? Do anyone Opera?
DuckDuckGo.
DuckDuckGo is a browser? Cool. I know that. It is Firefox. Look, it's fine. Look at that. Oh! Okay, I did all of these slides. I made these slides on an airplane. I spent 5.5 hours flying from Atlanta yesterday making these slides. My back and shoulders hurt. And that's weakness leaving the body. That's not actually true pain. Okay. And because I was doing that, I didn't have my usual browser set up, so I made these all in Chrome, so they're fine in Chrome. That's crazy. That's so cool. Okay. I'm not more into web browsers than machine learning. Do not put in course evals that I care more about. Okay. So a lot of people think IV stands for intravenous. No, it stands for feature. Specifically, independent variable, right? So what's going on here? We take the log of points, le points, yeah? Le points de Lyon, right? Okay. So we have the log of points, and we're using it to predict price. Should we do this? Maybe. When I think of points, I think of my beloved colleagues, other professors, right? And professors love to give points on things called homeworks. Have any of you heard of these? Yes. Yeah, so I know a thing or two about homeworks, having crossed swords with a few in my day. So on homeworks, for whatever reason, when humans grade homeworks, they happen to give very, very close to normally distributed score ranges because there's something wrong with humans' brains that they really like normal distributions, right? So my concern here is that this thing is already probably normally distributed because it is socially constructed, right? And maybe I don't necessarily want to be taking the log of that. Well, it doesn't really matter. So we're going to calculate this, and we're going to see what happens. The log of points, we're going to need a massive multiplier on that. Why? Because the largest point value, I think, is 100, which is, the log of that is 4.6. And I'm guessing a bottle of wine that's scoring 100 is probably getting somewhere around a $300 price tag. I don't know. Has anyone ever drank a bottle of wine that scored 100? You all drink box wine, don't you? You would have known. You would have been like, oh, that's like I can like hear angels sing, right? So I'd expect the coefficient to be at least 65 here, right? And it's much more than that because we have a large negative intercept, okay? Some of you may be following along in Python. sklearn by default assumes that you are not calculating an intercept. It only calculates slope. So there's some minute differences in all of these things. Sometimes it makes sense to assume the intercept is at 0, 0. For example, if you're measuring how many things happened since some day, at the first day, 0 things have happened and 0 days have passed, right? So you would have the line going straight through 0, 0. With wine, this neither makes sense or not makes sense because 0 points, I think the lowest point value you can get is 80. So these things are sort of unmoored and like unrelated to actual numerical values, right? So maybe we want intercepts, maybe we don't. Depends on it. Okay, so anyways, we logged the IV, which is a famous Batman villain, Poison Ivy. Okay, and a 1% increase there is a 3.24 increase in price. What are the units on price? It's 30 times 1 gram of gold bullion. You were very close. That happens to be the same thing as dollars. Okay? So, if rating increases by 1%, we see a 3.24 increase in dollars. Now, not too long ago, we should believe this, because not too long ago, I asked you what a $91 bottle of wine would cost if a $90 bottle of wine cost $30. And we agreed that it was in between $2.50 and $3 additional dollars, right? And that is also around a 1% increase. So this amount of change, about $3 for about 1 point, that makes sense. We've already found that somewhere else. So this should match our intuitive understanding of the data. We're adding 1 point to a bottle of wine adds 10% to the value, more or less, and that's what this is actually saying if we take a $30 bottle of wine as a baseline. Now, we only know that because as humans we have some prior knowledge about this, because otherwise we would not be able to rate this 3.24 to a percentage. Has anyone purchased a bottle of wine recently? How many dollars was it?
I think like 9.
Yeah, okay, so that's logarithmically close enough, right? 10% of 9 is 90 cents, and that's relatively close to 3.24. Did you have your hand up, Kendall?
Yeah.
Well, how many dollars?
I spent about
20? Yeah, okay, and 10% of 20 is about 2, which is about 3.24, right? We're within an order of magnitude. Okay. We can do logs of both, the log. This is apparently also called elasticity. Do you all know what that word means? Okay, then none of us do. Okay, a 1% increase in ratings equals an 8.3% increase in price on average. Why is this called elasticity? Because this is how much one thing changes when the other thing changes. This is related to the macroeconomic theory of elastic and inelastic goods and substitution, right? So this is how elastic the good is compared to other things in the economy. Wine seems pretty inelastic, which is kind of cool, right? It seems like people decide how much money they're going to spend on wine, and they go out and spend that much, and they don't look at the points too closely. That matches my intuitive understanding of how wine works, right? People go out and they say, I'm going to have a $50 bottle of wine today. Or they go out and say, I'm going to have a $9 bottle of wine today, right? And you don't look at the points, right? You get the $30-est bottle of wine. There's the famous scene from Brooklyn Nine-Nine, where the guy from Lonely Island asked for the $7-est bottle of wine at the wine cellar? Anyone remember this? Did I make that up? Okay, is that a real thing that happened?
And then they all show up at the party,
Yep.
and everyone has the same $7 bottle of wine.
Well, it
All
is
the
the,
younger people do.
well, because they optimized for the most $7, right? So they all found the same local optimum. Which makes sense because Brooklyn is a fictional setting. Okay. So across the river from me, where I live in the South Waterfront, Portland, there's a United States Postal Service postal office there that's called the Brooklyn Post Office, because apparently that neighborhood's called Brooklyn. So I'm actually from Brooklyn to here today. Okay. That slide was uninteresting. Okay. This is the same thing we already talked through, right? Blah, blah, blah. 8.3 increase, blah, 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 3250. I'm not supposed to tell you should just do arithmetic in your head all the time, right? That's something I'm very specifically not supposed to tell you. So I'm not supposed to tell you to do that, but that's how I figured out how all of this stuff works, okay? So, right. Blah, blah, blah. We did this already. Okay. Here's the same example. Wait, am I placing back or forward? Okay. It's also good to graph points by variety. Now, I already showed you the correlation plots for these three varietals, right? So you already roughly knew what the distributions of points in these different varietals looks like, and you probably remember that Pinot Gris was fetching lower point tallies on average. I think, is Pinot Gris a white grape, a white wine, right? And for whatever reason, I perceive white wines as having a harder time collecting large amounts of money and large amounts of points. I don't know if that's true, but I perceive it that way, right? And then I think Chardonnay is also white, but I perceive it as like the most prestigious white, or maybe way up there. I associate it with the Sonoma region, which might or might not be true. And then, of course, Pinot Noir is a very fetching grape. So I do expect Chardonnay and Pinot Noir to be performing slightly better than Pinot Gris. And so this matches what I expected to see. I don't know if I specifically expect to see this in Oregon, because I don't have a strong sense of how strong the Pinot Gris grape is in this region. And that's just getting a little bit too involved for me to do this without having to actually just look things up. But we could also argue that looking at this plot does count as looking things up, right? This is a more representative way of understanding the point performance of different varietals in Oregon than it does to read Wine Enthusiast for 10 years and try and remember them, right? Okay. Here's the summary. One of the things I noticed when I was looking at this is that those numbers are very close together, right? Going off my price prediction, I would expect a bottle of Pinot Gris to be only about 10% less valuable than a bottle of Pinot Noir, which means that if it is 11% cheaper to plant that grape, I should, right? And then the Chardonnay and the Pinot Noir are very close. I did expect Pinot Noir to be better than Chardonnay because I associate the Willamette Valley as a Pinot Noir region, and I think the Willamette Valley is the most productive region in Oregon. I could be wrong. But I don't know, these are pretty well. And then another thing that I think is happening here that I think we should all think about, I believe all of the wine scores are between 80 and 100. So these could be bang on average if we are normally distributed within that range. And we don't know if we're normally distributed in that range in terms of points, right? But these all being very close to the center line makes a lot of sense. And Pinot Gris being a relatively high, we'll say deviation from that amount, does make sense because I associate this with being a weaker grape in a slightly weaker region, right? Okay. Or I don't know if Oregon's a weaker region. It's an up-and-coming region. Okay, this thing's long, right? Why is it long? I didn't decide Chardonnay had that many letters in it, okay? I would have just called them Chards. Okay? Here's the regression table. We can look at the different whatevers for this, right? Why is this on here? Why is this slide so important? Do you notice how I only have 2 varieties in this table by default? Have I not been complaining about that unrelentingly ever since I walked into class today? Basically, right? This is an unacceptable tibble to generate, right? It does not have Chardonnay, and we know, because we were just looking at this thing, that Chardonnay is the most performant varietal. So if you just use the default performance of your tibble generation and look at your regressions, you might be missing the most interesting and most important data. And that's why I say what types of variables are we considering here. Not enough of them. Okay. This is the, these slides are the assumptions of linear regression that we were supposed to go over before I sent you off to dinner. I have resequenced things for a variety of reasons. But most importantly, you all seem more chipper at 6 o'clock than you do at 8 o'clock. So I've been trying to move doing activities time earlier in the day and then moving listening to me talking later in the night so you can fall asleep while I'm talking and not have to endure it as much, right? Okay, so these are some of the assumptions. We assume, wait, no, hold on. This is important. I want to state, for the record, it is important to make sure all of the assumptions of taking a linear regression are satisfied before you take a linear regression. Why is that? Otherwise, the data is garbage. I think there has historically been a temptation, and I really associate this with like the notion of like p-values and like anytime there's a summary statistic around, there's a tendency, I feel like, to over-index on it as being true because it is numerical. And we should not succumb to that bias. If we are going to use summary statistics, we should ensure we are satisfying all of the expectations of generating those summary statistics before we use them to make claims about the data. I am more convinced of wanting to make this entreaty to you after looking at the 91% for the New York prediction in the homework, and after looking at the understandings and explanations of RSME in the homework, right? It is well and good to look at numbers and be able to understand the numbers and be able to understand how to generate the numbers. It is also important that you are able to falsify the numbers. One of the ways you can falsify the coefficients of a linear regression is by finding any one of these violations. Here's an example of this violation. If you graph your residuals and they look like this, you needed to do either a polynomial or a logarithmic regression. I don't know. I can't actually tell by looking at this which one I should do, so I would probably do both of them. This looks atrocious, right? This is awful. Like, I don't really know what a beauty score and teaching score is, but my understanding, I clicked this link, and compared to the rest of us, because you all know what Jameson-Watts looks like, right? Okay, right. So I think some of us within the faculty are more sensitive to the impact of what we look like on our course evals because we don't look like Jameson, right? So I think this is the kind of thing that only Jameson would have put in his slides. And we're going to say it's because he wears a blazer every day, okay? Right? Okay. You always have to assume, or you have to have credible grounds to assume independence. And if you're going to assume independence, you need to check independence, and yada, 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 right? How do we check that things are independent? Well, one of the ways we like to look at this is you just plot the residuals, right? And so we've plotted the residuals here to look for nonlinearity. And we can plot the residuals here to see what form of distribution of residuals errors, right? The residue left between the prediction and the observation, right? We do not want to have those two branching red lines that I put on the earlier residual plot, right? This looks very, very close to normally distributed. There are ways to measure how normally distributed things are. Do you know ways to measure how normally distributed things are? Has that been covered yet? We will cover it if necessary. This is exactly what we want things to look like, right? We want to have a bunch of small residuals, and then we want to have the same number, roughly, of residuals at -1 as we do at +1. We don't want to have any big chunks anywhere. And then we also want to have, blah, blah, blah. Okay. We also want to have equality of variance. What is this? We make sure there's not a relationship between the point value and the residual value. That's the same thing as this thing here. Do you all like these jitter plots? I was looking at these. I used a bunch of them early on, and then I decided I didn't like them because they slowed my computer down. Right, there's in theory 130,000 points on this chart. And my computer's currently hot to the touch. Why would I not use one of these things? Right? There's, I think, 20 polygons here, and I think there's 130,000 polygons here. I'm assuming the circles are polygons. Ryan, why are you defending this? Defend it. You like it? What do you like about it? You like how many there are. You like things if there's more of them. So you like dollars more than grams of gold.
No.
But there's more dollars than grams of gold, Ryan.
I think that's probably true.
There's an infinite number of dollars. Yeah.
Dollars?
Yeah. There's, what is it? Okay, I have to move on because I don't know what we're talking about anymore. Okay. Don't do this thing where variance increases as numbers go up. This beauty score data set seems pretty wrong. But so, okay, so I think the beauty score was, if you ask on course evals if like the teacher is good looking or something, this like predicts that variance is higher for like high and low performing teachers or something. I don't know. Go read it. It's right here. It was a little too close to home for me. Like, I don't want to think about this. Don't perceive me while I'm teaching. I'm portraying a character. Okay. It's dinner time. Okay, we're fine. There's one thing I really like about this XQCD comic. I love polynomials. Who else loves, anyone love x squared? No one loves x squared? Okay, well, I really like polynomials, and I'm like inherently suspicious of exponentials and logarithms. So at various points in my life, I have done perhaps way too many quadratic regressions. And this really spoke to me. I wanted a curved line, so I made one with math. That is what I'm thinking when I make a polynomial regression. I'm like, looks like there's a lot of error in here. I should use a polynomial to make the error go away, and I do. And then what happens, right? Then someone asks you to explain what those coefficients mean. And you say, I don't know, or I don't even know how to find out, right? And that's the benefit of logarithm, where you say, well, when something increases by 1%, this other thing increases by 8.3%. Done. Easy. Always use logs and exponentials. I saw one of these the other day. I don't know what it means. Linear, logarithm, exponential, stay away from everything else is my recommendation to you. Is that wrong? Are you like, it's funny, but it's true, right? Like, there is very, very few naturally occurring polynomial relations. They do exist, right? And they're almost always related to like naturalistic phenomena, right? So, well, I've been complaining about my computer because I'm touching it, right? So the heat generation of computers is in fact quadratic in transistors per unit size and processor size, right? And so there's this weakly quadratic relationship where chip size was going down while transistor density was going up, and you would actually model that as a polynomial, right? That's not a log. The problem is it's also multiplied by a log because the number of transistors over time was increasing logarithmically, right? So it's a polynomial applied to a log. Okay, pre-processing and box guys. Okay, so we're going to pivot data sets. Some of you have been frustrated that we were working with 130,000 data points at a time. That someone is me. I was annoyed by that. That's why I was making fun of Ryan for liking the jitter plot. Keep that to yourself, okay? I respect you as a person. Don't make me download large files, okay? My computer is physically hot, right? It is like a professor that gets a very high beauty score. Okay. So a lot of people don't know how to pronounce this word, but you see it is pi followed by an not. So we would stylize that as pi naught, because it's pi raised to the 0th power. So that's pi naught. And so from now on in this class, we will use pi naught to refer to this term. Please don't do that. Okay. I have to breathe because I forgot to breathe for a while. What are the 4 assumptions of linear regressions? First one is linearity, right? Second one is independence. Third one, it's L-I-N-E. That's how you remember. Linearity, independence. Wait, could you not tell it was L-I-N-E? Yeah, it's in bold. Do I need to change the color? Should this be orange or something? Take the orange 4-inch door hinge from my best friend George. Okay, all right. Lots of things wrong with orange. Okay. Have you ever been looking at a data set and thought to yourself, I just wish I could press a button and cause this to become as close to normal as it could possibly be? I do this often, right? Anyways, this is a power transform. This is one member of the class of things called power transforms. There exist many power transforms. This one seems to be the dominant one in the sense of most usage and also very high simplicity. I found this one relatively easy to understand. There was some loud groaning when I showed some of the mathematics I went through to understand this thing. But what I actually did is I plugged in a bunch of numbers for lambda, and I saw what this actually turned into. And all of those things made sense. And I'm going to show you them to you, and I'm going to hope they're going to make sense. I come from a long tradition of people teaching this class. There's me, Jameson, and Hendrik, so that goes back pretty far. Professor Hendrik Orm has a math PhD and says he enjoys making students do some computations by hand so you actually understand things. And I sort of resonate with that. I understood things by performing calculations myself. You saw how I taught the log things today, right? It is much easier now than it was at any other point in history to generate large amounts of data and make a lot of assessments over it very quickly. This has significantly enhanced my ability to understand data by looking at it because I look at data all the time for fun. The competing point of view, and I think this has been advanced very convincingly by Jameson Lotz, is that you never want to look inside how these things are made because it's a little bit too easy to confuse yourself. So if you're going to get confused by this, simply close your eyes and pretend you're somewhere else. You do not need to be confused. You should only follow along as I substitute in values for lambda and talk about it if that is helpful to you. Now, what's this going to do basically? Well, essentially, y of lambda is a function that returns a function. We call these higher order functions in computer science, and I'm definitely not allowed to talk to you about those, okay? And so what this does is, given some lambda parameter, we are going to create a transformation. And an example of a transformation we could create is a log. That is the one we've been using. We could also create a polynomial. This is not going to create polynomials, right? This is going to create things that are an awful lot like logarithms. And why is that? Because lambda is a power over the x term. The usefulness of this specific way of formulating a power transform is this is going to have some nice properties around essentially -2, -1, 0, 0.5, 1, and 2. And these are many of the places we're often going to see transforms. So this is going to put us very close to what we want to see. One of the things to point out is that if you are using a maximum likelihood estimator of what your lambda term should be, and it comes back very close to 0.5, what you should probably actually be doing is just taking a square root. There's probably some naturalistic phenomenon that is causing you to have a square root. And when you're doing maximum likelihood estimation, you're slightly overfitting. If you get back 0.7, you should use the 0.7 because there's probably no naturalistic phenomenon, right? So have some intuitive sense of what might be happening to your data that's causing these things to happen. I will argue, as effectively as I can, that taking an exact naive log of price makes sense, because I think there are roughly half as many of things that cost twice as much. I think that's what happens with the economy. I think prices are roughly exponentially distributed for reasons arising from economics, so that makes sense to me. If I got this back and it said 0.7, I would assume something canceled out in the wash, right? Maybe it's a luxury good of some kind. I'm going to express this a few ways. I'm going to express it in LaTeX, and I'm going to express it in R. So I think this is a little bit too easy to lose. This is a function, y, the Box-Cox function, that accepts a term lambda, and the return value of this function is itself a function. It is a function that accepts one argument, x, and it returns a prediction. Okay, x to the power L minus 1 divided by L. And it occurs to me now L was the worst possible character to use for this because it looks identical to 1, right? So pretend that says lambda. Should I have written out lambda? That's what we're looking at. Okay. So, when lambda is equal to 1, this is equivalent to there being essentially no transformation of the data set. Why is that? Because subtracting 1 doesn't matter, right? X to the lambda, if lambda is 1, that's very close to, well, that's x to the 1 power, which is nothing. And we can show that by taking 1 to the 1, 10 to the 1, 100 to the 1, and 0.1 to the 1. And you can check this any way you like, right? We subtract 1 from that and we divide it by lambda. Lambda is 1, so that is x to the 1 power minus 1 over 1. Which, this is equal to x minus 1, which is very close to x. So we say that at 1, that shouldn't have a negative there. Y of 1 suggests that the f value is f of x equals x, the identity function. Then it gets extremely weird extremely quickly. I have slides from Hendrick and Jameson that claim at 0 this thing becomes a log. And it doesn't explain it that much, so I looked into it a little bit. And what I did is, are you all familiar with the notion of limits? Okay. The limit of this function as you approach 0 is the logarithm. That's a little too weird. Let's just look at some numbers. Okay, so when we take small values of lambda, so this is 3/100ths, 2/100ths, and 1/100th, which we see here in this term, right? There's the lambda value. This thing gets really, really close to being the same value as the log function, right? So I have f of x here. That's the Box-Cox function at this lambda value. I have the log here. And you see these are vanishingly close to each other, and they get closer as the lambda value decreases. So at 3/100ths, 2/100ths, and 1/100th, we get very, very close to exactly approximating the log. That's all you need to know. You can write an epsilon delta proof about that if you want to. Okay, we have another one. This is 0.5. If we substitute 0.5 in for lambda, what are we doing? Well, this is a square root, right? It is divided by 1/2, which means that this is times 2. So we essentially have 2 times the square root minus 1, and that's, that's basically the same thing as a square root, right? We only care about percentages when we're dealing with logs of things anyways. So this is approximately equal to the square root. Should it be exactly the square root, and would that be nicer? Maybe. This is where it gets really weird. I have a bunch of notes, not just from the other slides, not just from other colleagues, but I've looked at some textbooks and things that say when lambda is equal to -1, this function, the Box-Cox function, is supposed to be an inverse. There's only one problem with that. Let's take 10. The inverse of 10 is -10, because if I add 10 to -10, I get 0, which is the additive identity. But there's also one other inverse of 10, which is 1 divided by 10. And that's the inverse of 10, because when I multiply those things together, I get 1. And all of the textbooks I reviewed and all of the textbooks I read do not say which one of these inverses they're referring to. Because, let's see, this is the additive inverse, and then we have the multiplicative inverse. These produce very different values. What I'm pretty sure this thing is doing, it is actually both of these. It is the composition of these functions. And you're getting -1/10 back. And why do I believe that? Well, when I plugged in -1 here, that's essentially going to cause there to be an x to the negative 1, and it's on top of the fraction, so this sign isn't getting inverted. But it's on top of a negative 1, which means we're changing the sign of the fraction. So when I calculated this out, I got negative x to the negative 1 minus 1, more or less. But wait, where am I going? Oh, that's not what I meant to press at all. Okay, F11. The only reference I could find to the Box-Cox function where this is supposed to be an inverse makes this claim, that a lambda value of negative 1 corresponds precisely to raising something to the negative 1 power. I don't know how visible that is. And that is only the exponential inverse, right? And this is the only place I can find this on the internet. It's on statisticshowto.com. There are citations here, but I don't own these textbooks, so I couldn't read them. I checked to see if I could find them in a library real quickly. So this is the thing I told you was coming on, where I think, I don't know if this is an error or what's going on here. I found a different specification of Box-Cox everywhere I looked except those slides, or except this page. And even on this page, they specified this formula, which does not produce these outputs. So I don't know where this comes from, but I think this is what is built into a lot of languages. And I don't know what to think about this, and I don't think it matters, but it was pretty weird. I expected to find a solution in ISLR, which is the companion text, and I couldn't find anything in here either. If you happen to know what's going on here, please let me know. I think the way to do this is to not think about it, but we should be clear that numerical claims have been made about this formulation that I have disproven on this slide. So just be aware of that. I think if I were you, I would never, ever in my life look at this thing, and I would use this table and I would not think about it, because I think thinking is like the enemy. Asymptotically, these things are equivalent, so I think I can write a proof that it doesn't matter. Okay, let's move on. Just use the function. They're built into nfstats in R. They're built into SciPy in Python. Here's the Python documentation that convinced me that I was even more confused than I thought I was. Let's go. Okay, all right. So fortunately, we don't have to think about any of this at all. Is that good? Were you stressed out about thinking about this? Can I get a loud sigh of relief? All right. We have no idea what this thing is doing, and we don't care. All right? That's the way to think about this. All of a sudden, prices are very close to being normally distributed. Points are very close to being normally distributed. Years are very close to being normally distributed. Does that seem a little strange to anyone? I don't think years are normally distributed. That one really got me going. I wasn't really sure about that, so maybe these things should be factors. So I converted the years to factors. I don't know that you ever want your years to not be linear, but they're also not quite linear, because they don't really start in 0, 80, and or CE. We're saying CE is the norm, right? What did you all learn? Okay, all right, Common Era, which is not actually less Eurocentric. Okay, so we're going to pre-process this thing with the Box-Cox method, centered and scaled. The way to do this is, hey, I don't know how this is working. What's going on? No problem, I got you. This is how it works. Now, I was somewhat hoping that someone would explain to me how Box-Cox worked on any of these pages, and there is no mention of lambdas in here. I don't know what's going on here, but once again, this is yet another place that refers to the Box-Cox function, and I don't know how they get inverse at -1, right? Okay, so what do we have? We have line. We're going to turn years into factors, because we want years to not be Box-Coxified. We're going to pre-process with Voxcox, and then we're going to predict. There you have it. Okay. One of the reasons to force everything into a normal distribution that is scaled and centered is so that you can do the k nearest neighbors algorithm. A lot of people don't know this, but the k stands for Kendall. What does Kendall stand for?
Like, what does it mean?
Oh, I was asking you what you stood for personally. Sorry, I didn't mean to put you on the spot. So Kendall stands for Kendall stands for truth, freedom, and hard work paying off. Okay. So that's what the k nearest neighbors algorithm symbolizes. K nearest neighbors is quite simple. You are all sitting at a position in the classroom, and you can compute who your nearest neighbors are using, for example, Euclidean geometry. Can I get a whoop whoop for Euclidean geometry? Okay, so what's going on here? It was not immediately obvious to me what the assumptions of k nearest neighbors are. So I'm going to put this up on the screen, and I'm going to tell you this is sort of whatever. We imagine we have some data set which contains data points or observations for which some attributes are met. For example, the price and the point value of wine, but also perhaps whether a wine is a Pinot Noir or a Pinot Gris, right? We can feature engineer before we put this thing into k nearest neighbors. And we can imagine we have some classifications or perhaps even some numerical data type, right? And what we're trying to do is, given some known data, when we add a new data point for which we're missing some label, such as whether the wine is from Oregon or not, by measuring how close it is to other data points in the data set, we can attempt to infer a label for that data point. So we could say, for example, it is highly likely that a Pinot Noir from Oregon scores 90 points and a Pinot Noir from California scores 95 points. Here is a Pinot Noir that scored 91 points. Is it likely to be from California or Oregon? And we would say, many more of the 90 to 92.5 point wines, which are Pinot Noirs, are from Oregon. So we assume, because it is most similar to those, that it has the same label, that label being from Oregon. Our motivating example is going to be province prediction given features of our data set. This is academically interesting exercise, right? What can we infer about the terroir of certain regions based on the attributes of the wine reviews, right? I haven't read this. I don't know what it says. Let me show you what I read. We're not going to read that. This is how I understand k nearest neighbors. We have some red triangles. These, of course, symbolize the California wines. And then we have some blue squares, which, of course, symbolize the Oregon wines, because we're a bunch of squares up here. Shout out us, right? Is squares an insult? Is that okay? Can I call us squares? Is anyone's feelings hurt? Okay. And then, like a bolt of lightning out of the cloudless sky, we get a green circle. And someone tells us, well, do you think this wine is from Oregon or California? And we say, I don't know, because I don't know what number Kendall is, right? So if we're looking at, for example, a k of 2, we will look at the 2 nearest neighbors to this wine. We will take the Euclidean distance, so perhaps this is the distance in points along perhaps an x-axis, and perhaps this is a distance in some other value on the y-axis. What other features could wine have? Oh, I don't know, price. And so perhaps we have price by points, and we're trying to categorize whether something is Oregonian or Californian. And we see, this triangle is quite close, this triangle is quite close. The 2 closest neighbors to this are both Californians. How many of you have neighbors that are Californian? Up in Portland, everyone complains about them moving in and driving up our housing costs. I don't know if you do that in Salem. It's fun. Okay. And then we say, what if Kendall is 3? Kendall, what's your favorite number?
My favorite number is 72.
Can you pick a smaller favorite number?
My lucky number is 14.
Can you pick a dramatically smaller number still? 3. Oh, okay, I'm seeing 3. Okay, so Kendall's favorite number is 3.
Well,
So we're going to look at a k value of 3 because it's Kendall's favorite number, right?
I am a third child.
And so we take the 3, Kendall, we take the 3 favorite, thank you. Okay, we take the 3 nearest neighbors, and fortunately someone drew these handy dandy circles on here. So I can see what is at each Euclidean distance, right? And we see, there are 3 Oregon lines that are closer to me than the 3rd closest Californian line. So that means for a k value of 3, the nearest neighbor to green is blue, and for a k value of 2, the nearest neighbor to green is red. You should object to this immediately and say, how do you know that we have the same distance in both of these dimensions? That's why we just introduced Box-Cox. That normalizes all of our distances. So that's why we can assume we have the same distance in terms of in the price domain and the point domain or any other domain. That's why we applied this transform, this pre-processing method, using Carré. I saw someone spelled it like it was supposed to be pronounced Carré on a homework. I love that. Keep doing that stuff. That's fun. Okay. This example here represents using numerical distances to predict categorical data. KNN generalizes, and we're going to worry about that later. Okay. I loved this graphic. Everyone say thank you, Wikipedia. This one ruined my brain, right? Why is that thing red? It's right by these 2 blues. K is 3. These are the 3 closest. So that's why. So if there were a point up here, its 3 nearest neighbors would be red. If there were a point down here, its 3 nearest neighbors would be blue. This is a blue point that's 3 nearest neighbors are red, right? Look at that. Look at that. Isn't that cool? Seeing this point here really helped me understand k nearest neighbors. This is well documented. You can take a look at it here, right? Given the test point, and this is linked directly from the slide. You can just click on it. Okay. Oops. Okay. Here is one more example. This is, once again, we have an x-axis, perhaps representing price, and a y-axis, perhaps representing points. This graphic is lifted from Geeks for Geeks. You can go check them out. I didn't think their explanation was as good as Wikipedia. I don't think anyone's close to Wikipedia on this definition, right? I thought it was better than the textbooks as well. Say we have some target point. We want to classify whether it is more similar to these green circles over here or these purple circles up here, I think. We calculate the distance to various other points, and we use this to form a categorization. This is much easier to understand when we actually inscribe the circle on it. Can you see the circle on the slides okay? It's quite faint. There are 2 points here that are closer. There's 1 point here. If we extend the circle not that much, we'll capture this point slightly before we capture these 2 points. And so I think the 4 closest points are purple, and the 3 closest points are green. What this means is that your k value is always going to be contested, and Kendall's favorite number is going to be tumultuous and always in flux. Okay. To do our example, I'm checking the time because I know how many minutes I want to do things. Okay. You all ready for an exercise? We're ramping to an exercise, okay? If I were you at this point in time, I would make sure I've got my R installation up and running, and I'd start building this data frame along with me. Okay. We've got taster name, and we're going to lump it up. So this is going to take our 5 most popular tasters in a taster other category, okay? That's the first feature we're going to engineer. We're going to grab our taster names. We're going to remove the most frequent, and we're going to remove the selected. So we're taking out the taster categorical data. We're only going to have dummy variables left, right? Okay? And we've got our years as factors. We've got our taster names. Notice we are using these as categorical data. Okay, well, year is a factor, but the tasters are going to be categorical, right? Indicator variables. Think about what that will mean for your distances, right? These are all going to be 0, 1 distances, okay? We're going to apply a series of transforms to names. We're going to make everything lowercase, And we're going to make it snake case, basically. That's what's going on here. We're substituting our dashes and our spaces for underscores. Okay? We're doing that so everything lines up nicely. Okay. And then we're also going to add some tasting notes. If any of you talk to baristas, like I was doing during our dinner break, they all complain that everyone always asks for a coffee with chocolate tasting notes, which doesn't make sense because cocoa beans are from the Americas, and coffee beans are either from Yemen or Ethiopia. To my knowledge, no one knows. And neither of those places are in the Americas, right? So your coffee never tastes like chocolate. You just think that's what it tastes like because it's the only tasting note you know. If you think you've drank coffee that tastes like chocolate, you're wrong. I'm sorry. Your experience is not valid. Okay. Now, you might think you taste cherry. That might be correct. I actually have no idea what region cherries or grapes are endemic to. So by all means, enjoy that. And you might think it tastes like earth. Of course, everything tastes like earth. That's where we live, right? So we checked the description, which I think of as the tasting notes, to see if there's a note of cherry, a note of chocolate, or a note of earth. One thing should be jumping out at you here immediately. This is all in English. So that, like, I felt like I was getting beaten over the head with a, I don't know, Union Jack while this was happening. So anyways. All right, after we grab these 3 tasting notes, we rip out the description. We're not going to have the description around, okay? Why is that? All of the descriptions are going to be different. There's no reason to measure their nearness to each other. Now, I could bring a computational linguist in here and say, well, actually, we can plot these descriptions in some n-dimensional space, right? We're not going to do that. Okay, but you could. All right. We're just going to take the first 6 things here, and what are we going to look at? Oh, we've got price, points, years, year factors, whatever, dummy variables for the years, okay? And notice we have provinces. We have 5 good provinces and also California, okay? Is anyone from California? Yeah! Which part?
In wine country, I live like 10 minutes from Jackson.
Hell yeah, good for you. Do you know things about wine? You've been leaving me hanging this whole time. I've been like begging for help, and you've just been there, but like, well, it must suck to teach this class, right? Some of you have reported each time you run your code, you get slightly different answers, perhaps due to training, perhaps due to data partitioning. Set the random seed, which is the seed of number generation, to Kendall's favorite number, 505, after this class, Kendall's favorite class. And so I set 505 every time. What this means is that if you download this and run it, you should get the same numbers as me, even though this process is random, because it's going to be the same random, right? Okay, so we're creating a training test split. We're taking 80% for the training, and we're going to test on 20, and we are not going to return this stuff as lists. We're going to keep them as data frames, okay? We're going to specify a k-nearest neighbors model. What's this thing, KNN? Let me make this easy on you. I didn't love this. So when I typed in KNN, there's like KNN packages, right? And then there's also KNN functions. To me, the function is the entry-level type. I am using the KNN from the classification package, which you know, because when I included the class library earlier today, I made a point to mention that, right? So this is the class. And I said incorrectly before that data 505 is your favorite class. That's wrong. Actually, this is your favorite class. The R language class library is your favorite. I love being able to tell people what their favorite things are, right? So here's the documentation for KNN. I've explained the KNN algorithm to you, so you do not need to read this right now. We are going to train on the training data set, but we are going to remove province from it because we are going to try and predict province. We are going to see in the space of years and tasters and tasting notes. So all of these things are going to be tasty. We're going to see in the tasty space, ooh, should we call it the Tastyverse after Tidyverse? Spider-Man into the Tastyverse, right? Okay. And then so we're gonna look into the Tastyverse and not into the Provinceverse. There's no geography in here, right? And we're going to see if locations in the Tastyverse correspond to locations in the Provinceverse, okay? So So we're going to train on the training set, test on the testing set. We're going to look at the 5 nearest neighbors, because our favorite number is 5 after data 505. And then our classifier is going to be the provinces, right? What's CL stand for? Oh, I can check. It's the classifications. Okay. If I say classification problem to you, are you familiar with that term? It is the problem of how to take some data points and put them into different labeled categories, or classifications, or groupings, or sets, things of this nature in ordered collection. Okay, so I'm going to specify a Kendall nearest neighbor model. Okay. We trained this, and we are going to look at the kappa value. Kappa? Kappa, kappa? Does anyone know how to say Greek letters? It's kappa? Okay. So we have an accuracy of 93, or 0.93. We have a kappa of 0.90, lower, higher, upper, whatever, accuracy null. Very, very accurate. The accuracy, the kappa value is, what is this? Oh, I found this from a textbook, by the way. Where are you? Oh, not a textbook, right, this is a white paper. It's written by this person. It's about fruit. So, this is the description. The kappa statistic is the measure of the agreement for categorical items, such as whether a wine is from Oregon, or Washington, or British Columbia. Its typical use is the assessment of inter-rater agreement, so we would usually use kappa to compare one k-nearest numbers algorithm to another k-nearest numbers algorithm. For example, we would use it to determine what the k value should be. So it can be used to assess the k-nearest neighbors algorithm. It is formally expressed as follows. What is this? That is the probability P of A is agreement. P of E is the expected agreement. So this is just the difference between observe and expectation, which you are familiar with from statistics. We're always comparing observations to predictions or expectations. What is the expectation of k-nearest neighbors? Well, you generally just assume that things are going to fall arbitrarily into the different categories, right? So we're going to measure our performance against that. So, proportion of agreement expected between the classifier and the ground truth by chance, right? So, what we want is we want high kappa. Here is a rule of thumb I've been passed by the people that designed this course. They say that below 0.2 is not good, right around 0.5 is pretty good, and above 0.8 is almost perfect, and they also pointed out that we got 0.93, which should be ludicrously suspicious because we don't know how to do k-nearest neighbors yet, right? This means we're overfitting on something. I want to point out one other thing. These are all in the range of 0, 1. A root mean square error that we saw previously today happened to be within the range of 0, 1, but it did not have to be, right? This thing has to be between 0, 1 because these are probability numbers, right? This thing 0 to 1, this thing 0 to 1, that thing 0 to 1, and that's exactly 1, right? Okay, so we had 0.9, that's way too high. So somehow we are overfitting. Let's look at this data frame real quick. There's a lot of data going on in here. We got years. 2003. Is anyone's favorite year 2003? Yeah, good year, right? What happened in 2003? Probably something good, right? We've got 2007, not a great year. That one was okay. That one wasn't the best. Okay. 2011, that's the year I graduated high school. So, pretty bad year. Okay. 2015, that's the year I graduated undergrad and took my first machine learning class where I learned LaTeX and MATLAB. Okay, so that's how old I am. Jim Gordon is, of course, the character from Batman the Animated Series. Roger Voss is, of course, the character from an earlier exercise this term, and we've got some other tasters here. We've got, does that say Virginia? I expected that to be an A. Okay. And then we've got our cherry notes, chocolate notes, and earth notes. Okay. All of these things, one of the things to point out, price got box-coxed to range from -3 to 7. These tasters are ranging from 0 to 1. The cherry notes are logical. and then all of the taster names and the years are 0, 1. So we have much higher range over price and points than we do over years and anything else. Oh no, not over years, right? Year range is over 6. And then a year factor ranges from 0 to 1. So we should be suspicious that one of these things is a little bit too predictive. I didn't know a great way to figure this out, and it actually looks at like determining variable importance of a k-nearest neighbors algorithm seems quite painful. I looked into doing this, and the way it was recommended to do this is to find the nearest neighbors, find the distance to them, pick random points, find the distance to those points, and take the ratio between random points and the nearest neighbors. And do this for every single one of your variables and see which variable is dominating. That was like a triply nested for loop, and I was writing this on an airplane. So instead of doing that, I wrote a function that omits something by its prefix and then calculates k-nearest neighbors and shows me a confusion matrix. And this was approximately a bazillion times easier than the next easiest thing to do. So I removed everything that had year in it. I removed everything that had tasting notes in it, and I removed everything that had tasters in it. And I saw my kappa went up if I ignored years, went up if I ignored tasting notes, and disintegrated into a ball of flame if I took out tasters, which meant I was essentially only predicting off of tasters, and tasters were completely dominating my data set. Why is that? Because dastardly humans exist in a physical location, and so do provinces. Cherry does not have a location. Oregon has a location, and Roger Voss has a location. So, when we're trying to predict what region things are from, we are extremely likely to be able to predict that by seeing who tasted the wine. This is extremely annoying, but also makes a lot of sense, right? This raised a lot of questions for me about the legitimacy of wine ratings. I think we saw like Roger Voss like essentially only drinks 98s, 99s, and 100s and also lives in Burgundy. I don't know how convinced I am by that now, right? It seems like you should mostly use point values now for intra-regional comparison. I should compare ratings between Oregon wines, and I should not compare ratings across geographic regions, because we have a strong evidentiary basis with this k-nearest neighbors algorithm that there is very little mixing across regions and across tasters. And that's what I would expect to have peer review over tasting quality. Can I hear it for academic peer review? Yeah, we love peer review. Okay. So we can simply rerun this data. And when we do this, we can see what the full confusion matrix is. I didn't print these out for all of them. Oops. But you see the biggest problem here is everyone can't tell Oregon and California apart. And the obvious reason for that is that Portland is closer to wine country in California than San Diego is. So actually, Oregon is part of California. Can I get a whoop whoop for California? They're bullying you. Don't let them do that. Stick up for your home state. Okay. When I say Oregon is part of California, that's actually meant to drive a point home. Burgundy is on a different continent than California. It is several thousand miles away. The Casablanca Valley is on a different continent than California. It is several thousand miles away. And Marlborough, I guess that's in New Zealand, which is several additional thousand miles away from either of these two places. And as you know, New York is the setting of Spider-Man Into the Spider-Verse and is a fictional location. That's why it has so few wines, right? Okay. I was teaching a class this weekend to an international student who was talking about how, like, outside of the United States, everyone thinks that all of the United States is like Los Angeles or New York City because that's how it's depicted in the media. And I said, no, that's actually true. So the kappa value is 0.348. Low but not terrible, right? That was in our pretty good range, right? Good kicked in right at 0.4. We have some confidence intervals and so on. Here's the statistics by class, because we have classification, right? So our class is California, and so on. Notice we're highly specific to New York and relatively insensitive, and then those are inverted for California because California wines are such a large part of the data set. I believe, and I do not know for sure, that California is geographically larger, population larger, and economically larger than every one of these other regions put together. I've been wrong before. Okay. Last thing to show you before I turn you over to do your exercise. You can just bootstrap this, and then you get improved performance over time. This is getting slightly better. You're not seeing too much better. The best thing is at K33, which is 0.35, still pretty low. We're still in the test province. We still have the Oregon problem. And then you can also use training with the metric of kappa. I did a low training control value because I didn't want to be here all day. But you see with this, our maximum value is 13, which is, I have to look down to see it. I try to look up because I feel like I'm supposed to be talking to all of you, and then I just look at the screen in the back. 3.7, all of these values are pretty similar, right? So we're not getting a ton of value out of training and subsampling either. You see we have some high points in the neighbor plot, but again, this is hyper-compressed. This is ranging from 0.34 to 0.37. Okay, this is group modeling problem number 1. You have 30 minutes, and you are supposed to try and get a kappa value over 0.5. What I would like your takeaway to have been from the last 4 or 5 slides is that screwing around with k-nearest neighbors is not going to take you very far. What you are going to have to do is engineer features. I would like you to learn in this class from this example, and I've been impressed with the importance of this by people that I believe and trust, that feature engineering is absolutely going to dominate the algorithmic power of even the most advanced algorithms we have in this class. Having some actual understanding of the data you look at is going to be far more compelling. I thought about this for a minute. I've been thinking about this for weeks, and some of you may have looked ahead as well. What do we have that actually differentiates these things? I made the point, and it was a throwaway this before all this revealed, that people say absolutely everything tastes like chocolate. That's just not going to help us that much. We have to look for something else. I have heard legends that some wines are perceived as like spicy. I'm wondering if that'll be a little bit novel. Something of that nature. I'm wondering if there's peppery or grassy tasting notes. I'm wondering if we need to look at something other than tasting notes. I'm looking at, we need to look at the combination of score and year, and we might be able to detect good years in different regions. These are the kinds of things I was thinking of, and I just wanted to point you in that direction. Form groups, perhaps join your k-nearest neighbors, and then you can go ahead and do this modeling and try and get over 0.5 in the next 30 minutes. And I will walk around and talk to you after I get a drink, because I've been yelling for 2 hours, so I'm going to go drink. Any questions before we start? Ready, go. I'm going to go get hammered.
Yep, do it.
I'm going to go get turned on tap water.
TNT.
Everybody good? How are the vibrators?
Make some new features.
How are the vibrators? It's a made-up model.
And as I know from learning some of these homework, they definitely work. 1000%. They work very well. Oh, and how to get exploring explores. Okay. Hear me out. Food tasters. We predict. Yeah.
It's been running.
You know what? I ran into this.
I am just so smart.
I will say, as far as I can tell, or I thought I was getting how bad was it? That's like not
What are some
not that many.
Are we writing
you to submission that one data set. Description. That's it. Okay.
Make sure the one user is not the one because that's what
What is the long for someone's last name?
And now I'm getting points off.
That's the
Okay.
That's crazy. I didn't hear that.
What if mine was the words in their descriptions?
Because I did earlier, I think that one.
I like that.
Which last time I actually, oh man, I realized no, I didn't. Haha, man, I'm so smart. For some big brain. And as you do, as I'll show you, it's a huge predictor.
that's why okay.
Very large. It's very important. Someone's telling me something isn't right there.
It's because that's not the thing, yeah. So, yeah, I just got it. But did you get it right?
Because you have the Google connection there. I don't. That's why.
So I
Hold on, let me go and have the F. Because you were telling me that the error is with those selected columns.
So basically,
Yeah.
this,
Okay.
I don't actually have like but this is stuff. Because this is
I had to switch the select columns to select and just did it as like a tidy or something. Because I was like, if it is true, this true, so I was like, that was going to be something that's the dummy calls. So I just removed the select here from the dummy calls. Yeah.
Yeah. What did you put for how many caps
Just have like the data set there's a whole
Yeah. You ran it from there. That's different. First time. Didn't you just run it from the after the first time? Just play.
Yeah, we want to be in charge of it. Survey. Schedule. Availability.
Did you run this beforehand? And that worked? Okay.
Yeah, is it Tuesday? See, the thing is,
If it doesn't work.
And I have that here, and I'm way sure. I'm just thinking if I could
What if you just ran, oh, wait. Okay. Get it back to where I told you. Or what, this. So you guys take it down to like the select. That, and then.
oh my god, I deleted all my tables because I got frustrated. Yeah, that's what I got. No, I deleted all my tables because I got frustrated.
Make sure you take out that.
one of these things.
So I just was
I did something with my head start.
Also, really stuck on that. Honestly, if you really are.
See, I don't understand why it seems so true.
Did you load the Fast Dummies data set? Looks like it is loaded, there's nothing came up. Actually, no, it's just
Yeah, that's definitely.
no? It's just, I have no idea. If that's somehow goes in my I don't know either, there's really Like call, you know. Is it right? That looks like just the base.
That's right.
It's got most of it. Everything. All right.
And it's because there was one here that was, even though it sounded so stupid, for some reason.
Where do we at?
No, I'm testing right now, so I just added like mine too. I ran into it on yeah, I got that exact same error on the other one, and then I started using the downloaded one. I just didn't want to
But just doing like a sort of here it says yeah. But it,
In the detail.
yes.
I hate features.
I did. It's just not.
And all the, I added like 4 new columns and it made my Kappa go up and stuff for it. So, I'll have like 28 more columns.
Try to just make a new box and try to run to just that.
Oh, okay, yeah.
Welcome to Coro. You also missed. Terribly. Like really badly. Do you need glasses? He has glasses.
Oh wow.
Fair.
Yeah, I put that. If they're the US, Mexico, or Canada, then put it they're from there. Otherwise, don't.
No one cares. All right.
Yeah, yes.
Obviously.
Awesome. Thank you. I don't know why it didn't like it before. Yeah.
there. It's within the.
Yeah. That makes sense.
Well, you're supposed to do that, because otherwise they get angry.
Yeah.
Or you introduced NAs when you did that because it didn't account for when the catacombs were somewhere in there. So I would just try NA dot open it first and create this.
Parentheses, parentheses, yes.
And then just put it right again.
This.
Yeah.
Okay.
So instead of doing what you did, use str detect, and if it's or panda, or if it's US or panda, just do one. If it's not, do zero. Yeah.
And then save that to.
Oh, I mean,
There you go.
That's a possibility.
We're just looking at that.
Instead of like doing US and Canada instead of
So this is bottom one column over here. So if we're going to this is the so then if we take these values, so this is taking these values and transforming it. So this being one column doesn't specify enough to get another different past experience, right? And this is essentially you want to remember what the years are. That's why we need to get over
Oh, yeah. Okay.
because we don't want to. What is it called?
The work
Something that actually works.
Right. Shoot, it's like this.
Easier way.
So what this is written so when
After dinner, we switch to party.
Oh, it's in early expression.
it's hard to do. I want to get my part because it's probably represent a bunch of different categories, right? And then we have dumb right? So dumb variables.
Yeah.
And basically it's
find
each
out.
double variable is like, is this kind of local variable to this physical?
There is, but I didn't want to run
That's why you
top.
and then the other
Might be able to do this.
And it doesn't.
Now we're gonna do a different thing. It's like,
Always.
And then I actually use this too.
This would be this.
I thought I was trying to do this thing. I don't know what I'm doing. I was trying to
Just put it
that's the best one.
Just let it do its thing for a second.
I have a feeling. Yes, you want. If you want. Let's look back at the data frame and see how all of it is.
Thank you, Kendall.
I would love to find out if
I'm real good at it. I'm real good at it.
That's what happens when you
No. We'll find out.
Yeah, no, yesterday when I tried to when I forgot to remove those data frames, I took this tab.
This specific one, that's it.
great.
Unless you turn it all, you're never gonna go to this.
Because, okay, using the 1K,
I mean, yeah, if I should taste or something, particularly.
I will, I had to finish the one assignment that was for today. And now I have 24.
You worry it's like crap tomorrow.
See, the 1K reason fine, but then when she goes to run her model, it gives a bunch of warnings.
Okay.
Like I'm talking like, say, like 5 or 6
Cannot
terminals,
allocate that precise
and won't basically. So, and I guess part of that has to do with the fact that one mouse was done for teacher engineering, dropped all the MAs and then goes to 0.01. They get that about it. It's like that. So it needs
But no, it's
process.
my
Yeah.
It's
And now it's getting angry because I'm saying that you can't sample less than the population. So the population is 89 days. 10K is less than 89 if I've passed my math class. And so now I'm trying to figure out.
no expected to end soon. When is it snowing? Never.
I remember when I wrote samples.
Thanks, Wonder Fang. Very cool.
Sample takes being, okay, it wants a vector, that's what it wants, okay. Not a data set.
Reason.
Reason.
I was like, oh shit, I should check it. It's been cold. Yeah.
Class is over, drive safe.
Is it snowing?
It's like, basically,
No,
this is trying to predict like which problem.
It's beginning to look a lot like Christmas.
Yeah.
Everywhere you go.
I just don't know instead of snowing.
I don't know.
Basically, I'm always the same.
Okay, wait, hold up. No, I'm gonna focus on this and then I'll come back to that. Thank you for help.
I added the word fruit at one point, said
Did it work?
yeah, and I was like, oh, that was after I had but I'm 40.
It's my good job.
Yeah, we call that just AI. Oh, good point.
Seems like that's what
It's just the AI generates.
easy. Well, I got rid of it, and then it got bad. This you can show me.
Yeah.
Don't want to learn that.
Do you say with N?
Oh my god.
Yeah, I got it.
Where am I saying? You're gonna use stamp anywhere you want. So like here, that's basically the database, because after that, it's some like. That works.
What the hell happened here?
Yeah, so I don't know that there's like. Okay, so the scientific way to do it is with like pretty intensive communication. One of the things I think to think about this question is like,
It's still probably
I were like super wine. I would be telling you stories about like, oh, I had this wine once that had these tastes, and I had it, right? And I don't really know how to do that, but I do know how to think about like, what are foods that have the taste mechanic that they taste better? It's like, oh, some of them taste like pepper, some of them taste like spice. And so just like the words we heard people use to describe foods that like are all like right? And then we can think about like, oh, if I had a wine, like what properties would I want? Would I want it to feel like warm, or like minerality, or like anything? And then you can also say like, oh, I should like read what reviews from wine and taste like.
I don't know what it is.
And the reason to do all this is the same data scientific approach we use for everything. Where like any data set we look at, we don't actually know what's going to necessarily be important in there. It's really hard to approach that like purely scientifically without any external. Especially in this type of program,
at this point, I'm like, it is
specifically
what
with
it
master's data
is.
science, right? I want you to like bring in your own impressions and your own possibilities. And like even if you've never heard anything about wine, like how do you do that? Right? Or you bring water or something, right?
I'm just straight
And
up
so
like,
just think about like, what would I like? What do I think other people would like?
Where did you,
And look at that stuff. And then the way to get better at doing that is to like test your assumptions and see if they are correct. Right? So you're like, oh, like I really thought like a pepper taste would be positively associated. It's like negatively associated. Like, oh, what should I think about that? That would be my approach. It's just like iteratively try things that sort of make sense to you. And over time come to a conclusion of what
oh, I see.
Good question. Does that help?
I remember when I did that one where both of us but it was because it was a lot of I wasn't able to figure it out.
Like the outside.
Yeah, it was the last question.
Yeah.
I was able to get a room and I just wasn't able to figure it out. Well, I just think
Why?
Some
Why?
people be targeted for like their intent.
I just wanted to.
it's not too bad.
If someone asks you about it. And so like, it's only,
I'd be so mad. I'm like, damn, I did all this work at
it's not enough for me to look at the last one. So like on the homework assignment, or and then they can just write a response about that. And that is right. And that's fine.
My homework assignment. So this is what I did. I submitted something over my class.
Yeah, I'm just updating my meal planning for the week, so I know what to buy at the grocery store.
Based on the changes from the baseline that is the order unmentioned. Right. So.
If you talk about that.
Okay. I was just wondering, like, that was a distinction that was.
Yeah, that's me.
Okay. Yeah.
I think like.
I understand why it's not like
caring
obvious to
about-
someone,
yeah.
but like, that's like how what I've learned.
Yeah,
from-
yeah, so even like, I'm willing to agree that also like, a lot of that's not necessary. What I think I'm looking at is that you were thinking
Yeah, it was like a whole thing. It was not.
Yeah.
you thought about it, that's all.
Yeah.
You just have to think.
Mine usually took a couple minutes.
Yeah. No, that's fair. That's fair. Yeah. I was just wondering because like, yeah, like all of this output and minus one things. So I was just wondering like, yeah. But if people are, the difference is if the output and minus one thing is equal on top of and minus one thing, then that is obviously wrong, right? But
Yeah, to me it makes a lot of sense.
yeah. I was looking at
Yeah, well, it's like half a block. You waiting for me?
Yes. So hold on, there's a section of creates known variables for it says create three new features that is interaction, time, and those variables. And what I understand creating interactions with features with operators.
Hey, you can do it.
So like with a year, how long?
Yeah, so you can convert the year to the factors that and you can do a year across.
So the existence of GPA which is just essentially an inclusive AND versus a
We're just trying to figure it out.
it becomes a logical operator.
Yes.
Okay.
Over the, yeah, all
So
the
like-
categoricals are fluid.
Okay.
And in fact,
So then,
yeah, you could also have that.
Oh.
It's not.
Was I not supposed to run it
That's
under
why you have 20.
Okay, well, how many times am I supposed to run it?
Like 10.
What?
Like 100 times.
Yeah.
Are you kidding me? What?
I really agree with
There's different kinds of categories.
what?
What does anything mean anymore, honestly?
I don't know. I have no idea what meaning is.
Meaning is the gerund form of to be
Oh my
mean.
gosh. I'm putting 10. It's so low.
Do you need another 1 week extension?
No, I don't want to. Okay, I turned in the week one homework.
Yeah, I think I saw it come through, I think.
I need to send you know with the link, but it's,
Okay.
it's up.
Okay.
It's up. I don't need another week.
You need to do things on the cloud instead of on your laptop, is what you need to do.
I just need it to run.
Use Posit Cloud.
Wait, is it my laptop that's
It's pretty easy to see if it's the laptop. Touch it and see if it's hot.
I love it. Especially when
it's
it's
only
frozen.
slightly.
Then it could be something else.
My fingers. It's burned my fingers.
That's what I love to hear. What is going on?
But that was because that
Oh, I'm still streaming.
the stupid thing.
What's up, YouTube?